The hearing will come to order. And without objection, the chair is authorized to declare recess at any time. I know there are many hearings going on, so hopefully we will gain more people as the time passes. Let me welcome Administrator Bridenstine, and we have a lot to cover at today's hearing, so I will come right to the point. You have stated that NASA's fiscal year 2020 budget request is a good one, apparently in part because the President didn't cut your budget as much as he is proposing to cut the rest of America's federal R&D investments. And we consider rather misguided and harmful cuts to DOE and NSF's research budgets. So I'm really not that persuaded. In fact, I find both the NASA budget request and your written testimony for today's hearing to be a little disappointing. The President's budget request for fiscal year 2020 proposes the same ill-advised cuts to important NASA science and education initiatives that it did last year, cuts which Congress has already considered and rejected in fiscal year 2019 Appropriations Act. Eliminate NASA's key STEM activities, the MURAP, the Space Grant, and EPSCoR, the highest-ranking astrophysics decadal priority, the WFIRST, and 2 critical Earth science missions, PACE and CLARIO, made no sense last year, and we think it doesn't make any sense this year. I have little doubt these cuts will be rejected by the Congress again. Yet it is in the area of human space flight, which accounts for half of NASA's budget, that I find your written testimony most troubling and non-responsive. Relying on that testimony, I would have no idea that Vice President Pence, presumably speaking for the President last week, directed NASA to undertake a crash program to put astronauts on the moon within 5 years, by any means necessary, to quote the Vice President. And what is the most justification for this crash program? To quote the Vice President again, it is because we're in a space race today just as we were in the 60s, and the stakes are even higher. Moreover, according to the Vice President, the Chinese have revealed their ambition to seize the lunar strategic high ground, whatever that means. The simple truth is that we are not in a space race to get to the moon. We won that race a half century ago, as this year's commemoration of Apollo 11 makes clear. And using outdated Cold War rhetoric about the adversary seizing the lunar strategic high ground only begs the question of why, if that is the Vice President's fear. The Department of Defense, with this more than $700 billion budget request, doesn't seem to share that fear and isn't tasked with preventing it from coming to pass. However, rhetoric isn't the same as a credible plan, and this committee needs to see if there is any substance to this crash program. The Vice President's directive to NASA came just 2 weeks after the Trump administration submitted its NASA budget request to Congress. Moreover, it is to be completed within the same 5-year budget horizon that is contained in the President's fiscal year 2020 budget request. Given the absence of an urgent crisis, it would be the height of irresponsibility for the Vice President of the United States to direct NASA to land astronauts on the moon within the next 5 years without knowing what it will cost, how achievable the schedule is, and how it would impact NASA's other programs. I expect, Mr. Administrator, for you to provide us this information today before this committee, as I assume you provided to the White House on each of those questions in advance of the Vice President's speech. The committee needs to know how much money will be needed in each of the next 5 years to carry out the crash program. We need to know how much, if any, money the President proposes to add to NASA's budget over the next 5 years and the extent to which NASA's other programs will be cannibalized or cut to fund this initiative. We need to know if our international partners will be part of it or simply frozen out, as some of the rhetoric would seem to suggest. We need to know if the International Space Station will have to be shut down within the next few years to free up funding for the lunar crash program. In short, we need specifics, not rhetoric, because rhetoric that is not backed by a concrete plan and believable cost estimates is just hot air. And hot air might be helpful in ballooning, but it won't get us to the moon or Mars. Mr. Bridenstine, I, like many of my colleagues on this committee, strongly supports NASA. And we want our nation to achieve challenging exploration goals like landing humans on Mars. If the moon is a useful and necessary waypoint on the way to Mars, then I believe Congress will support a sustainable exploration program that includes the moon. But NASA has to date provided no meaningful roadmap to Mars, despite congressional direction to do so. And if you're not able to provide us with credible specifics at today's hearing, I think a great disservice is being done to the hardworking and dedicated men and women of NASA. They need programs and funding plans that are sustainable and inspiring, not a constantly shifting set of directives. I can assure you that this committee will do its part to ensure that NASA can continue to be the inspiring leader in space exploration, science, and technology and aeronautics that it has been for the past 6 decades. And this hearing is just our first step. So I thank you for being here. I know you've read many of the news clippings that we have read, questioning what the plan really is for NASA, and I hope that we can get some answers. If there are members who wish to submit additional opening statements, you may do so later, but I now recognize Mr. Lucas for his opening remarks.
Thank you, Madam Chairman. Our nation's space program is a source of pride. It exemplifies the greatest aspects of our country: the pursuit of knowledge, heroism, technical excellence, perseverance, and the intrepid spirit to chart a course into the unknown. Exploration is in our DNA, and no other nation embraces that gift more than the United States. The Trump administration has harnessed our spirit of exploration and proposed to focus our efforts to pioneer space. By maintaining consistency for major programs like the Space Launch System, Orion, and Commercial Crew, the administration is ensuring that our national goals to explore the Moon, Mars, and beyond will be achieved rather than delayed. This consistency of purpose has also been demonstrated in this administration's funding request. At first glance, the President's FY2020 budget request appears to propose a reduction from FY19 enacted appropriation. However, that does not tell the whole story. Year after year, the Trump administration has proposed increased funding for NASA, only to have Congress appropriate even more than requested. For context, the current request calls for more than $21 billion, while the previous administrations proposed a nominal budget of just under $20 billion for FY20. This administration has added over $1 billion to NASA's budget request, and that's before Congress appropriates final funding. This is a blessing and a curse. As many watching this hearing have heard before, no bucks, no Buck Rogers. You have to remember the comic strip to appreciate that, but believe me, NASA is getting the bucks. Now it's time to deliver. Too often programs become complacent when funding is taken for granted. Congress and NASA need to work to be good stewards of the taxpayers' dollars. We need to ensure these programs stay on schedule and within cost. Congress, along with the reconstituted National Space Council, led by Vice President Pence, provide this oversight. Last year, the Space Council directed NASA to study efforts to fly crew on the first SLS mission. More recently, they reviewed ways to accelerate the Exploration Mission 1. Last week, the Space Council met to review the current status of our exploration program. The Vice President challenged the nation to return astronauts to the Moon by 2024. The current budget request that we are evaluating today does not enable that goal. I look forward to NASA updating their request so the committee can review those details. Aside from the budgetary unknowns, we do have a robust proposal on how we can achieve lunar exploration by 2024. The proposal focuses on the development of technologies that enable future exploration rather than dead-end, one-off technologies. The goal of once again launching American astronauts on American rocket from American soil is fully enabled by this proposal. The budget request plants the seeds for technologies that will be necessary in the future, like landers, habitats, and in-space propulsion. It also proposes exciting new programs like the Mars Sample Return Mission. Science funding in this budget is nearly $680 million more than NASA planned for FY20 under President Obama's last request. This additional funding maintains support for the Europa Clipper mission, the Mars 2020 rover, and the James Webb Space Telescope. It also supports Earth science and heliophysics priorities from the National Academies of Science and the foundational research and analysis work that forms the backbone of our space science enterprise. Aeronautics funding under the proposal is robust as well. It supports the demonstration of a low-boom supersonic technologies that will hopefully inform regulatory relief of supersonic flight over land. It also addresses hypersonics that are critical to our national security technologies that will enable the air traffic management and allow the safe adoption of uncrewed aviation systems. Importantly, the budget request is also responsible. It attempts to rein in programs that bust their budget and defers the start of programs until they can demonstrate realistic cost, schedule, and performance metrics. The request funds the maintenance, operation, and facilities necessary to enable our space program. All too often, these enabling functions are ignored, but we shortchange these obligations at our own peril. Thankfully, this request recognizes the role that safety, security, and mission services serves to facilitate space exploration, advance science, protect lives, and sensitive information. Mr. Administrator, thank you for your appearance today, and I very much look forward to your testimony. You back, Madam Chair.
Thank you. Thank you, Mr. Lucas. At this time, I will introduce our witness, James Frederick Bridenstine. Was sworn in as NASA's 13th administrator on April 23, 2018. Prior to his nomination, he served as a representative for Oklahoma's 1st Congressional District in the House of Representatives. And during his time in Congress, he served on the Armed Services Committee and right here on the Science, Space, and Technology Committee, as many of you well know. We are delighted to have the administrator back before us today, and we look forward to his testimony on the fiscal year 2020 NASA budget request. He has a history in the space and aeronautics field. He began his career in the U.S. Navy, flying combat missions in Iraq and Afghanistan. After transitioning to the U.S. Navy Reserve, he returned to Oklahoma, where he became the executive director of the Tulsa Air and Space Museum and Planetarium. He has completed a triple major at Rice University, which is in Texas, and earned his MBA at Cornell. As our witness should know, you will have 5 minutes for your spoken testimony, but your written testimony will be included in the record for the hearing. And when you've completed your spoken testimony, we begin a round of questions. Each member will have 5 minutes to question the panel. Mr. Bridenstine.
Thank you, Chairwoman Johnson and Ranking Member Lucas. It is an honor to be back in the Science Committee, this time representing 17,000 of our country's finest employees at NASA. I understand, as the Chairwoman identified, that things are shifting. I will tell you that we submitted the budget request about 3 weeks ago now. And in that budget request, there's a very new direction for our country. The President has issued now Space Policy Directive 1. He says that we should go back to the moon. I like to say we should go forward to the moon, because the way we're going to do it under Space Policy Directive 1 is unlike anything that's ever been done before. We're not going to the moon to leave flags and footprints and then not go back for another 50 years. This time we go, the President has said he wants to go sustainably. In other words, this time when we go, we're going to stay. But he says we're going to go to the moon, we're going to go with international partners, we're going to build a coalition of international partners to go sustainably to the moon, we're going to go with commercial partners, we're going to utilize the resources of the moon, in other words, the hundreds of millions of tons of water ice that have been discovered in the last 10 years. And then we're going to retire risk, we're going to prove technology, and we're going to take all of that for a mission to Mars. So that is what is on the agenda here. I will tell you the first step in achieving that is continuing to advance the commercialization of low Earth orbit. And we have now seen commercial resupply of the International Space Station prove to be very successful. And we are in the midst of watching commercial crew continue to show advancements, which has been very exciting. I think many of you in this room saw the Crew Dragon docked to the International Space Station just a few short weeks ago. Eventually, by the end of this year, we will be launching American astronauts on American rockets from American soil to the International Space Station for the first time since the retirement of the space shuttles in 2011. So that is a very exciting thing that we're looking forward to. But that's commercial crew. We've already completed commercial resupply capabilities, and eventually we want to get to commercialization of human habitats in low Earth orbit. All of this for the point of this. We think it's important, and I know this committee has doubled down on this importance. NASA should be one customer of many customers in a robust commercial marketplace in low Earth orbit. That includes launch, it includes habitation, and we want to have numerous suppliers that are competing on cost and innovation in low Earth orbit. The reason for this is to drive down cost and increase access, and then utilize the resources that have been given to us by this body to go to the moon sustainably with our international partners and our commercial partners, to do things that only government can do. That's what NASA should be doing. And we look forward to advancing that agenda. In this particular budget, these agenda items are embedded in this budget. I don't want to dismiss, though, how important the rest of what NASA does is. Right now, we have the Parker Solar Probe in orbit around the sun, in fact, flying through the solar corona, helping us better understand solar flares and corona mass ejections. We have, of course, dozens of satellites orbiting the Earth, sensing the Earth in every part of the electromagnetic spectrum, and those satellites are helping us better understand the climate and helping us, in fact, increase crop yields for a day when we can feed more of the world than ever before. At the same time, we're continuing planetary missions. And as a matter of fact, in the last, I guess, 5 months now, we landed InSight on Mars, which was an exciting day for the United States of America. In this budget, you'll find that Mars 2020 is well funded. You'll also find that there's funding for a Mars sample return. Mars 2020 is going to cache samples, and then after Mars 2020, we're actually going to bring samples back to Earth. It's important for this country to focus on finding life on another world. I'm looking at my good friend Ed Perlmutter with his 2033 bumper sticker. It's a little distracting, Congressman, but I'll continue. So planetary science is important. Of course, astrophysics is important. We're focused like a laser right now on the James Webb Space Telescope, which is a big mission. It will make the United States the leader in astrophysics for the next 30 years. That's how important this mission is. The budget is strong on aeronautics. We're on the brink of demonstrating a capability to fly across the United States at supersonic speeds without the sonic crack that can be so disruptive to infrastructure and people on the ground. So all of these missions are funded in this budget. We're proud of it. It is absolutely true, Chairwoman, that the budget was focused on a 2028 moon landing. We have now gotten other direction from the president to go in 2024, and we are moving rapidly to get you the details that you need so that we can, in a bipartisan way, and I've committed to you, Chairwoman, and I'm committing to you now, in a bipartisan way, we want to be able to achieve that objective. With that, I'll yield back.
Thank you very much. At this point, we will begin our first round of questions, and I'll yield 5 minutes to myself. We appreciate all that you brought to NASA, and appreciate you being here this morning. 2 weeks ago, 2 weeks after the administrator released the fiscal year 2020 budget request, Vice President Pence announced that the United States would send Americans to land on the moon in 2024, 4 years earlier than the 2028 goal included in fiscal year 2020 request. What is the justification for this crash program? What will it cost, and how achievable is this accelerated schedule?
I think it's important for the nation to continue advancing our progress, and for us as leaders of this country to demonstrate a continued advancement. And I think that's ultimately the objective here. I know I just saw Ed Perlmutter put up, Chairwoman, the 2033 bumper sticker. We want to achieve a Mars landing in 2033. In order to do that, we have to accelerate other parts of the program. The moon is a big piece of that. By moving up the moon landing 4 years, we can in fact, and I know you've probably seen the Stippy report at this point, which was called for by this committee, we can move up the Mars landing by moving up the moon landing. The moon is the proving ground. Like I said, if we have to be able to utilize the resources of another world. And on the moon, we now know that there's hundreds of millions of tons of water ice. Water ice represents air to breathe. It represents water to drink. It represents fuel. Liquid oxygen, liquid hydrogen is the same fuel that powered the space shuttles. It's the same fuel that will power the SLS rocket. So we need to utilize those resources. Remember, when we go to Mars, we're going to be there for at least 2 years. Why? Because Earth and Mars are on the same side of the sun once every 26 months. So we need to learn how to live and work on another world. The moon is the best place to prove those capabilities and technologies. The sooner we can achieve that objective, the sooner we can move on to Mars. And that's ultimately the objective here.
When were you first told that the Vice President was going to direct NASA to land astronauts on the moon in 5 years? And were you informed before the fiscal year 2020 budget release, or did he ask for you to provide him information on the analysis regarding the crash programs and the cost and the feasibility prior to his speech?
So the Vice President and I had conversations about accelerating the path to the moon. And we had conversations about what that might look like, what is feasible, how is it possible. And then ahead of his announcement, yes, he had told me that he was intending to make that announcement, and he wanted to make sure that that was within the realm of possibility. And of course, I told him that I believed it was. Of course, I talked to folks at NASA, and at the end of the day, that's the new direction that we have, and I believe that this is a great opportunity for this agency. I think it's a great opportunity for the country, and I think we can move out on it and achieve it.
Thank you. Now, how much funding will be needed in each of the next 5 years to meet the Vice President's 2024 directive?
So that goes to an amendment to our budget request, which we are working on right now to achieve. The elements of getting to the moon in 2028 are all present. So we know we need to accelerate SLS and the Orion crew vehicle with the European Service Module. We need to accelerate the Gateway, the power and propulsion element, habitation module in orbit around the moon. And then we need to accelerate a landing capability, which would include a transfer vehicle from the Gateway to low lunar orbit, a descent module, and an ascent module. All of those elements are on the agenda for 2028. In order to achieve 2024, we need to take some of those elements and move them forward to achieve that objective. And what we're working on right now at NASA is compiling the data necessary to come back to this committee, to come back to Congress and ask for an amendment to our budget request and attempt to win the buy-in of this critically important committee and the United States Congress.
Thank you. Do you think you can achieve that by April the 15th?
I think we can get really close, yes, ma'am.
Okay. Thank you very much. My time has expired. Mr. Lucas.
Madam Chair, before I begin my official question time, I'd like to ask to speak for a moment out of order, introduce a new member to the committee.
Yes.
Thank you, Madam Chairman. Jamie Herrera Butler represents the 3rd District of the Southwest of Washington State. She's done great work already on advancing STEM, conserving important resources, and driving technology progress. So welcome to the committee, Jamie. You'll find this is a fun committee, and that's not always the circumstances everywhere. Thank you, Madam Chairman.
Thank you, and welcome. And when you mention STEM in any of your conversation, you get my attention. Mr. Lucas.
Well put, Madam Chair. Director, this FY20 budget request for NASA is $21 billion and $19 million in change, so to speak. The Obama administration's last request for FY17 planned to request $19.879 billion in FY20. How does the extra $1.14 billion request schedule for this year enable exploration, science, and aeronautics? What's the difference between the two?
So the focus now is getting humans to the moon as soon as possible. 2028 was based on the budget request. And the intent, of course, is to not just get humans to the surface of the moon, but prove that we can live and work on another world. And that's really what the extra resources have been applied to.
Continuing down that road, the budget request proposes delaying continued development of the exploration upper stage for the Space Launch System that, along with advanced boosters, is necessary to meet the Congressional directive to develop a 130 metric ton launch vehicle. Why is NASA delaying that effort on the capacity?
Mr. Ranking Member, what we have found is that the development of SLS has proven to be more challenging than previously anticipated. So what we have attempted to do at NASA is focus Boeing on getting the core stage of SLS complete, and then from there we can move to the exploration upper stage. But the key is to be able to launch American astronauts to the moon, and we can do that with an SLS core stage and an interim cryogenic propulsion stage, and then we can get to that near rectilinear halo orbit around the moon where we're going to build the gateway. But the key is, and I agree with you completely, we need an exploration upper stage. The key is we've got to get the SLS built or the exploration upper stage isn't going to be usable.
So we're still committed to developing the 130 metric ton launch vehicle?
Yes, sir.
Because if we're going to throw big things up, we've got to have a big capacity to do that.
Yes, sir. In this budget request, the intent was to delay. We have no intent to cancel. We're trying to get SLS complete so we can get humans in the vicinity of the moon as soon as possible.
Director, 2 years ago, Congress passed the Weather Research and Forecasting Innovation Act, which I sponsored and featured yourself and Ms. Bonamici as the original co-sponsors. Title III of the Act created a pilot program for NOAA to procure data from the private sector that could be integrated into the National Weather Service forecast. The law also directs NOAA to avoid duplication between public and private resources and data. The goal was to stimulate the private sector to provide data to protect lives and property and ensure U.S. leadership in weather forecasting. The FY20 budget request for NASA proposes to spend millions of dollars on sensors aboard the European Sentinel-6 mission to conduct global navigation satellite system radio occultation observations, what a phrase, to ingest into the U.S. forecast. U.S. companies are currently providing GPS radio occultation data to NOAA. This administration, and you in particular, have been stalwart advocates for commercial space enterprise. How is NASA ensuring they're not competing with the private sector? Aside from the direction in the 2017 Weather Act, current U.S. commercial remote sensing policy also directs agencies to rely on maximum practical extent on U.S. commercial remote sensing space capacities for fulfilling imagery and the needs of the military, intelligence, foreign policy, homeland security, and civil users. How are we balancing that public-private?
Sir, this is a critically important issue that our nation needs to be focused on. As you are aware, GPS radio occultation under laws passed by this committee and this Congress have enabled us to, for the first time in history, use commercial GPS radio occultation data and ingest it into our data assimilation systems and our numerical weather models and in fact derive results that are meaningful. In other words, commercial data is no longer going to be really just a pilot program, but we're looking to operationalize that commercial data because of the work of this committee. And for that, I will tell you, our nation is grateful. As far as the operational use of GPS radio occultation data from our European partners, NASA is not involved in that. I would defer to my NOAA colleagues on how they intend to I guess, work that issue. But know that commercial data is a critical piece of the mix, and I'm happy to take that and get you a more complete answer after talking to my NOAA colleagues.
We'll follow up because we certainly don't want to push private industry out of the spectrum as hard as you and I work to make that possible.
Yes, sir.
With my remaining moments, Madam Chairman, I have the privilege of also introducing one more new Republican member of the Science Committee. Jennifer Gonzalez Colon represents Puerto Rico, which has a large R&T industry and a commitment to innovation and research. Jennifer is also a proud graduate of a STEM magnet high school, and she's told me she's excited to work on promoting STEM education. So you have another ally, Madam Chairman, when it comes to STEM.
Thank you very much. They can keep on coming. Thank you.
Yield back, Madam Chairman.
Thank you very much. Ms. Bonamici.
Thank you so much to the chair and ranking member, and welcome back to the Science Committee to our former colleague, Administrator Bridenstine. I appreciated our early efforts to work together, and thank you, Mr. Lucas, for pointing that out. And I hope we can continue to work together to support NASA and its historic mission and its workforce. And I understand you have many priorities to balance when writing the fiscal 2020 budget request. I say I'm disappointed to see a shift away from the multi-mission role, which seems to be contrary to congressional intent in recent reauthorizations and appropriations to restore funding to NASA's Science Mission Directorate. NASA has some of the very best scientists in the world, and as we face the consequences of climate change and extreme weather patterns, we should be doing everything we can to leverage information from Earth-observing satellites to strengthen our understanding of climate change and identify successful adaptation and mitigation strategies. And as a co-chair of the House Oceans Caucus, I'm also glad to welcome the new members who have districts that are definitely affected by ocean health. I know that the health of our natural resources, specifically marine resources, is critical. Warming waters have been triggering harmful algal blooms, which cause a serious problem to marine life and human life and our economy as well, and investments in research to predict and adapt to those challenges is important. So I'm looking at NASA's PACE mission, the Plankton Aerosol Cloud and Ocean Ecosystem mission, that could help us understand algal blooms in their relation to other environmental events, for example. So that's scheduled to launch in 2022 and will improve NASA's satellite observations of ocean ecosystems and the atmosphere. However, Administrator Bridenstine, despite demonstrated value shown in the January 2018 National Academy's Earth Sciences Decadal Survey, the Thriving on Our Changing Planet survey, your budget proposes to terminate the PACE mission and justifies this decision by stating that existing and planned missions from other NASA, NOAA, and international partner satellite fleets are providing or will provide measurements to establish similar science. It's worth noting that the PACE mission is known for having the most advanced ocean color instrument in NASA's history. So what are the other federal government and international satellite efforts that are providing, or you say will provide, similar results? And is there a consensus from the scientific community that the same data products of the same quality that would have been in the PACE mission will be delivered from other missions? So, and did you consult with other scientific researchers involved with PACE before making this decision?
So that's another important question. Know this, Congresswoman. As of right now, PACE is funded by Congress, and we are moving out on it very rapidly. It is a good mission, and NASA believes in it, and we're working very hard to achieve its launch in 2022. It is also true that it's early in the development phase, and when we consider all of the things that we're balancing, that was one of the casualties of ultimately making decisions in a constrained, budget environment. But it is also true that there are other missions that NASA has and our international partners have that help us characterize the color of water. Specific missions that I can take that for the record and get back to you what those instruments may be and on which satellites and
And did you consult with the scientific researchers involved in the PACE mission when making this decision to terminate the program?
We did. We consult with all of our missions when making these critically important decisions.
I have another question. Last Congress, we passed the NASA Transition Authorization Act, reaffirming the sense of Congress that the administrator should set science priorities by following the guidance provided by the scientific community through the National Academies of Science, Engineering, and Medicine's decadal surveys. And I'm concerned that the proposed budget does not align with this principle. I'm especially concerned about cuts to earth science. Can you explain the lack of funding in your budget request to initiate missions and implement the most recent earth science decadal survey? And based on your fiscal 2020 request, when could we expect decadal surveys missions to be initiated and launched, and when will they be funded?
Yes, ma'am. So as of right now, we have the highest earth science budget in the history of the United States. And if you look at our earth science budget compared to that of all the other nations of the world, if you add up the European Space Agency and Canada and Japan and Russia, our partners on the International Space Station, collectively their GDPs are higher than ours, and we're about equal to spending as much as all of those nations combined on earth science. I think our earth science budget is very good. In fact, this particular earth science budget request is higher than 5 of the budgets that were enacted under President Obama, which is a solid, I think, position to be in. And I know you and I have talked. My commitment is and will be to do everything possible to make NASA an apolitical, bipartisan organization. I want to drive consensus, and the way we get consensus is to listen to the decadal surveys from the National Academy of Sciences, and to the best of my ability, I have done that, and my commitment is to continue doing that.
Thank you. My time has expired. I yield back. Thank you.
Thank you. Mr. Posey.
Thank you, Madam Chair and Ranking Member, for holding this hearing. It certainly is good to know that our days of reliance on others for human access to space are limited. And great to see you back here, Mr. Bridenstine, as administrator.
Thank you.
Can you provide an overview of what preparations are being made at Kennedy Space Center to support the first launch of SLS and Orion on Exploration Mission 1 next year, as we prepare to receive and process the rocket and the spacecraft at KSC? What activities are taking place now to ensure that smooth stacking, integration, and rollout will all happen?
Absolutely. So at Kennedy, the exploration ground systems are key. Of course, having a mobile launcher is key. Those are under development and getting very close to being ready. The first SLS, we have had some delays with, as I've already explained. That's why we're so focused on it. In order to achieve getting that SLS to Kennedy as soon as possible, we've made some significant changes in how we're actually developing it. We have found that, and we did not know this ahead of time, we have found that the engine section of the SLS is actually on the critical path because of the complexity that was unanticipated. And the challenge is the rest of the SLS rocket was dependent on that section being complete before it could be integrated. And that was based on a property, plant, and equipment limitation that we had. So what do? We've now purchased new equipment, I should say new tooling, so we can start integrating the oxygen tank with the hydrogen tank, with the inner tank and fairings. We can actually do that in the horizontal while we're continuing to work on the engine section. So that's accelerating the path. And of course, once that is complete, we will do testing on the entire integrated vehicle through what we call a green run. We're making determinations right now. Ultimately, how much of a green run we need to do based on the schedule that we are attempting to achieve. And I want to be clear, we're going to be very safe. We're not going to do anything that brings undue safety. But if there are things that we're testing that are nice to haves and not necessary, then we're going to look at moving those to a later test. But at the end of the day, we want to get the rocket to the Kennedy Space Center. We want to make sure that the launch pad and the mobile launcher are ready to go. And all of those are not in the critical path right now. I think we're in good shape for those activities. And I can tell you, everybody at Kennedy is extremely excited about getting the first launch of SLS by 2020. And that's what we're working on right now, getting it by the end of 2020.
Well, thank you very much for your direct answer. And I appreciated your comments last week about the importance of the exploration upper stage for the SLS, the second mobile launcher.
That's right.
That will launch the more powerful rocket by Exploration Mission 3. These upgrades will allow SLS to launch both astronauts on Orion while also carrying the large payloads, lunar landers, and so forth. Although NASA's fiscal year 20 budget process proposes deferring the work until several years out, it appears that based on the Vice President's charge that we accelerate the return and the immediate development, and your comments all seem to jive. And so, if so, how will NASA continue and accelerate EUS and ML2 development this year in
Yeah.
FY20?
So just so you're aware, this is an important issue and you're hitting the nail on the head. Under the law, we are required to build the second mobile launcher. And what we do at NASA is we follow the law. So we are right now, in order to build that second mobile launcher, which is required by law, we are continuing to develop the exploration upper stage in a limited way. Like I told Ranking Member Lucas, we want to focus on that core stage, but in a limited way, we need to continue development on exploration upper stage so that we can follow the law and build that second mobile launcher. My commitment, sir, is to follow the law, and we will continue doing that. But it is true that right now, if we're going to accelerate the agenda to 2024, we're going to have to make decisions as to what the level of investment is going to be and make a modification to the budget request to achieve that agenda. And we look forward in the coming weeks working with OMB and the administration, coming to you with a plan to achieve that. And that's like the chairwoman said. Keep going back to my old days. Like the chairwoman said, we want to get that to you as soon as possible, hopefully by April 15th.
Thank you very much, Mr. Bridenstine, and I yield back.
Thank you very much. Ms. Horn.
Thank you, Madam Chair. Good morning, Administrator. I want to start by saying I have a statement that I've submitted for the record that should be over there. I want to start off by talking, I think you made a good point about this is not a partisan issue and it shouldn't be, but I think there are some important unanswered questions about how we're going to achieve the things that have been proposed and some clarity. So in the congressional justification for the FY20 request, it states that NASA's Orion spacecraft and space launch systems are the backbone for deep space exploration, from which private companies could one day provide equivalent commercial. I think the conversation about the appropriate balance between government and commercial is critical. But as the Senate committee hearing, that you mentioned that you were considering the use of commercial vehicles to launch Orion on an EM1 mission. So in your prepared statement for today's hearing, you also said that NASA is also assessing alternative architectures for the EM1 that could include the use of commercial launch vehicles. But at the same time, on March 26th, in a press release, you were quoted as saying that while some of these alternative vehicles could work, none was capable of achieving our goals of orbit around the moon for the EM1 within our timeline and on budget. The results of this 2-week study reaffirmed our commitment to SLS. So I guess given these conflicting statements, can you tell me what the final decision was on that?
Yeah, absolutely. So the answer is the 2-week study is complete, and we looked at all of the commercial options, and we took nothing off the table. What is the realm of possibility, and how do we achieve a 2020 launch with an Orion crew vehicle and a European service module? We looked at a Delta IV Heavy. And I don't want to take up all of your time, but we looked at a Delta IV Heavy. It doesn't have the throw weight. With an ICPS at the top, it gets even heavier, and it still can't make it to Earth orbit. So then we said, oh, what about 2 Delta IVs? The challenge there is you only have 1 launch pad on each coast. If you launch from the west coast, you have to launch south, which means you have to change orbits once you're there. A lot of Delta V, a lot of time, cryogenic boil off. It doesn't work. So then we said, what about launching a Delta IV and a Falcon Heavy? And what if we were to put a Crew Dragon on top of a Falcon and do automatic rendezvous and docking, which is the only capability we have right now as a country, is that Crew Dragon to do automatic rendezvous and docking with the Orion. The challenge there is the Crew Dragon doesn't have the thrust to throw the Orion around the moon, so that didn't work. So then we looked at way out of the box. What if we were to consider putting a Falcon Heavy with an Orion service module, or the Orion crew vehicle, and a European service module, and an ICPS from ULA? And I know that sounds crazy, but again, we're looking at all options, and in fact, it works. It requires a lot of modifications to the launch infrastructure, to the launch pad, to the erector arm. It takes a lot of modifications to do cryogenic and hypergolic refueling on the pad, which doesn't currently exist. It takes a lot of time, and there's a lot of cost, and there's risk. And it wouldn't work for accelerating a 2020 launch of an Orion crew vehicle. But what it did demonstrate is that if you have a little bit extra time, 2023, maybe 2024, a lot of that uncertainty could be retired. And if we're going to get
So just because I have a few more questions
Yes.
that I want to get to, so can you boil it down to the final decision? Because I appreciate you looking at all those things, but can you boil that down to the final decision that we're still on track with the SLS for EM1?
Absolutely.
Okay.
SLS is the best. In fact, it's the only option for EM1. And there are options in the future that need to be considered. And when we land on the moon in 2024, it's only
Okay.
because of all of the above strategies.
There's a couple more questions I have, and I'm just going to boil them down really quickly. Actually, I've got quite a few more, but focusing on the accelerated moon landing and the how we're going to get there, for moving it up even another 5 years from where we were. There are, with these announcements and moving it up, what is the need for the lunar demonstration programs, given this proposed accelerated timeline? How are those programs going to be impacted?
They're important. So, we have the commercial lunar payload services underway, where we're going to purchase the access to the moon commercially. We're going to small payloads, 10 pounds or less. Can you deliver it to the south pole of the moon so we can characterize the water ice, understand kind of what is the value of the specific territory where we want to land? So those missions are underway right now. They're critically important to helping us understand where, when we land humans on the surface of the moon, where we want to place those humans.
Okay. My time has expired, but we'll be submitting some more questions for the record. Thank you.
Yes, ma'am.
Thank you very much, Mr. Biggs. Okay, Balderson. Or Cloud, she said. Balderson.
I apologize, Mrs. Chair, I didn't hear you. Good morning.
Good morning.
My first question to you would be, the FY20 budget request calls for the elimination of NASA Office of Education. I believe that we need to be encouraging hands-on STEM education, which NASA has supported in the past. Could you elaborate on how NASA will continue to support STEM education while zeroing in on the education account?
Absolutely. So NASA does this all the time through the various mission directorates. NASA does it all the time through the various centers across the agency, and we do it when we partner with universities with critically important projects and programs for the agency and our exploration mission and our planetary science missions. So we have a broad kind of STEM agenda that is funded in a whole lot of different ways. That specific Office of Education is a small piece of everything that we do. I can give you an example. A couple of weeks ago, I was at a FIRST Robotics event, and there were thousands of kids there. NASA sponsors it to the tune of about $4 million annually. Why? Because if you look at the people that are building our robots that are currently on Mars, they were participants in FIRST Robotics when they were coming up through school. So that's an amazing program that has paid dividends for NASA and, in fact, for the country. And so what we like to do is focus on areas where we know we're getting a return for the agency and a return for the country. And again, given the constraints of the budget, we've decided to focus on those areas.
Okay. Thank you. I have one more question. In your testimony, you talked about the importance of the Lunar Gateway in order to continue manned missions beyond the low Earth or orbit. I think it's important to recognize the hard work being done at NASA, the Glenn Research Center, which is just north of my district in Ohio. My team had the chance to tour the facility that is working on the development of the power propulsion element at NASA. Glenn and found the work to be fascinating. Could you talk about the importance of work being done at research centers around the country?
Absolutely, and that power and propulsion element that's going to be part of Gateway, when we talk about Gateway, some people think of it as like a space station in orbit around the moon. It's very different. This is, in fact, it's a reusable command and service module that is going to enable our astronauts and our robots and our landers and rovers. It's going to enable us more access to more parts of the moon than ever before. And the reason that's possible is because of that power and propulsion element. Solar electric propulsion at thrust values that are greater than we've ever been able to achieve before with solar electric propulsion. So that's very high specific impulse. It means that the fuel is going to last a long time. The goal is for the Gateway to remain in orbit around the moon for a period of 15 years to be able to go from that near rectilinear halo orbit all the way up to the L1 point and the L2 point, which enables all of our capabilities to get to more parts of the moon than ever before. So that power and propulsion element is critical.
Thank you very much. Madam Chair, you're back my retaining time.
Thank you very much, Mr. Perlmutter.
Thank you, Madam Chair, and Mr. Bridenstine, thanks for being before our committee today, and it's good to see you. Initially, when I came in, I was disappointed in the report that came back on the pathway to Mars, because they basically said, well, given the constraints that NASA faces and budget and all this stuff, we don't think we can get there for a long time, was more or less what they said, which really was disappointing to me. And quite frankly, I was very encouraged by your initial comments to the chairwoman about the desire to get to Mars by 2033. And I don't mean to be a one-trick pony on this, but I think it drives a lot of other conversations. And so, you know, it's a responsibility of the Congress to provide you all with the resources, and the pressure that you felt from the White House, and not you, but NASA, to accelerate returning to the moon, you know, being able to survive on the moon for extended periods of time. Quite frankly, for me, I'm okay with that, because I think it accelerates the effort to get to Mars, which I think is the underlying driving force here for inspiration, as well as for NASA to just really expand and continue to expand its capabilities and its imagination. So I really don't have too many questions. My responsibility is to continue to talk to this committee and to others about this goal. Something that's interesting, and this is sort of outside of the context of this committee, is when Vice President Pence says we're in a space race or we've got competition, there is an element of national security that is attached to that, somewhat. It's not just the civil side of our budget that is implicated in that. And so I'm going to be turning over every stone to provide the resources so that you guys, the technical, the science, all that stuff, to get this done. And I'll just have an open-ended statement to you about that, and you can respond.
I will tell you, Congressman Perlmutter, your leadership on this has been amazing. In fact, when I came over here, I said, look, I'm going to see my friend Ed Perlmutter, and I need to get a bumper sticker that says 2033 on it. I didn't have one in my office. Don't know why I didn't have one in my office. I should have. But I walked into an office just down the hall, and I stole one from somebody who works at NASA. So just know that your efforts have been felt and seen and heard throughout NASA, and we're grateful for it. And we are doing everything we can to accelerate that agenda, because you're right, Mars is in fact the horizon goal. The moon is the tool that we need to get to Mars. The glory of the moon is it's a 3-day journey home. We have seen what happens when there's failure on the way to the moon. With Apollo 13, people can make it home safely. If that were to happen on the way to Mars, it would be a very bad day for the country, and we don't want that to happen. So the moon is the tool to get to Mars, and we're doing everything we can to accelerate.
Thank you. I yield back.
Thank you very much. Mr. Gonzalez.
Thank you, Madam Chair and Ranking Member, for holding this hearing today, and obviously a big thank you to you, Mr. Bridenstine, for your work for our country and with NASA. Like Troy, I have the distinct honor of I represent Northeast Ohio, he's Central Ohio, and we're home to the NASA Glenn Research Center, as you know. Quintessential research center for achieving NASA's vision and mission. Having visited the center recently, saw firsthand just how incredible the scientists are, the engineers, the technicians working there, over 3,000 strong. Just absolutely amazing work. As you may know, Midwest has suffered from the loss of manufacturing jobs over the last decade. Look no further than our recent closing in Lordstown at the GM plant. It's my belief that in recent years, certainly with the Glenn Research Center, NASA has underutilized the commercial aerospace resources and human capital of Ohio and nearby states. What can you do or think about to ensure that Midwest capabilities and capacities are recognized in the procurement and development of goods and services obtained by NASA?
That's another very important question. We are working every day at NASA to make sure that we're taking advantage of all of our centers and all of the talent that we have. And we always consider the talent internal to our agency before we go outside the agency. And what you know very well is we have a lot of talent. Yep. The power and propulsion element, as we just discussed, is a critical piece of the future architecture. But the aeronautics capabilities of Glenn are really second to none. We're talking about wind tunnel technologies. We're talking about the ability to test engines, to increase fuel efficiency, to, in fact, improve the environmental standards of aircraft. All of these things are being done at Glenn in a very meaningful and positive way. And they have implications for our country. When we talk about exports, when we talk about how important our engine manufacturing is around the world, we are able to maintain this very cutting-edge capability in the propulsion sector of the aviation market because of the efforts of people at Glenn and other research centers throughout NASA.
Thank you. And then shifting gears, in your testimony you highlight the importance of aeronautics and the U.S.'s leadership in the global industry. As Russia and China continue to make investments in their domestic aerospace sector, I think it's more critical than ever that NASA continue to lead in the fundamental research that will help the U.S. aerospace sector remain competitive, especially in commercial aircraft and autonomous passenger and cargo systems. Administrator, can you talk about how important the aeronautics research that NASA conducts is to our aviation economy and how NASA can better position itself to ensure the U.S. is a leader in aviation research? So kind of take a strategic lens on it, if you could.
Absolutely. So what we have to think about is what does the future of aviation look like, and how does the United States of America remain preeminent in that space, really for our own economy and for exports. And that's really where NASA plays. There are some very leading-edge investments that might be too high risk for a for-profit company to invest in, but we can come alongside and support them in that effort. And we've done that. I don't know if you look at engines these days on aircraft, and as a pilot, I look at these engines, I'm like, man, these engines keep getting bigger and bigger, and the point now where the engines are flat on the bottom because they'll hit the ground, that kind of thing. What is driving that? Well, these are reduction gear capabilities developed by NASA with partnerships with our commercial industries, ultimately so that we could increase fuel efficiency, reduce noise, and have better environmental standards without losing any kind of power or thrust. So those bigger turbofans are a direct result of NASA investments, and we want to keep doing that. It's also important to note a couple of other things I think are important. We want to be able to fly from New York to LA in a matter of 2 hours instead of 6 hours. We want to have an ability to fly supersonic across the United States without a sonic boom that is disturbing to people and infrastructure. That technology is being developed right now so that at the end of the day, FAA can give us a determination that it's perfectly okay to fly supersonic over the United States. We're working on that. And then when we think about urban air mobility, the idea that you can order something and have it delivered to your front door with, no kidding, a drone in a matter of minutes. That capability is on the horizon. And eventually, the idea that we're going to be able to fly humans across a city and avoid traffic with urban air mobility. Like, we need to be thinking about that today. There's billions of dollars of investment going into these activities all over the world. The United States of America needs to be in the lead.
I completely agree with you. Thank you for your time, and I yield back.
You bet.
Thank you very much, Dr. Foster.
Thank you, Madam Chair, and thank you, Administrator. Let's see, a quick question on the 2024 launch date. Who made that decision to change it by 5 years?
That was a decision by the President of the United States, announced by the Vice President of the United States.
Fascinating. Okay, were technical people consulted and
Yes.
budgetary people consulted?
Yes.
And was the question asked what that would do to the budget at the time that the command was given?
The determination was made that we would need to make an amendment to the budget requests, and we're working on that right now.
And you're doing that on a zero-sum basis, or are you going to be allowed to increase the total for NASA? Or are you going to cut other programs?
Oh, I will tell you, it will not be successful if we're cutting other programs, because we have to have bipartisan support.
So you will be asking for an increase. And were there, was it specified who would be taxed to do that?
Will there be taxes to
Yeah,
that?
taxes. If you know, if you're going to make increase the budget, normally you have to tax someone to pay for it or to specify what else you're cutting.
That would be a determination by somebody other than the NASA administrator.
Okay. All right. Now, just you're talking about, you know, essentially a program based on chemical rockets that would be completely understandable to Wernher von Braun. Everything you're proposing. And there have been, for decades, conceptual designs for ways to get stuff into low Earth orbit for much less. For example, these are things like electromagnetic launch systems, air-breathing systems, space elevators, Lofstrom loops, all this sort of stuff. And it seems like you're spending a negligible amount of stuff that actually has a chance to reduce the cost of getting stuff into low Earth orbit. And is that something that bothers you, or have you considered moving the needle on that so that actually we have a chance 50 or 100 years from now with having space be affordable to people, which I think is pretty clearly not going to happen if we just keep using chemical rockets again and again?
That's an important question. You're absolutely right. Chemical rockets are expensive. We're making really great advancements right now on the reusability of rockets, which is driving down cost and increasing access.
That's not a major effect. I visited SpaceX, when this was still conceptual, hadn't been proven yet, and I asked the question, okay, if you reuse the booster, how much, let's say it all works and that they're able to do it. You reduce your capacity to low Earth orbit because you have to retain fuel to land the booster. You have to go and take stuff apart, respace, qualify it, everything. How much money do you actually save? And the answer from the engineer at the time was you save 17%. That is not transformative. We need a factor of 10 in the reduction of costs, not whatever number you get from reusability of the first stage booster. So you have to spend money on transformative technologies, and I don't see that anywhere in your budget. And is that how do you view that trade-off?
So I think, again, I think it depends on what your definition of transformative technologies are. I will tell you
something that could get a factor of 10 in the cost to low Earth orbit. Okay.
Look, if there's a way to get a factor of 10 reduction in cost, I'm all for it, and I'd love to hear your ideas on it. I know you're a physicist, and I'm all ears.
It relies on fundamental research. If you want to make the space elevator work, you got to get long carbon nanotubes in mass production. These are things where they're good ideas on how to spend the money. But if you concentrate more and more on let's go to the moon with the exact same technology we used 50 years ago in the next 5 years, the money that's spent there is not being spent on something that can actually make space accessible to large numbers of Americans 20, 30, 50 years from now. So I urge you to rethink the trajectory you're on. In a similar way, space nuclear power is something that you're working on. And the trade-off the decision you have to make early is whether you're going to use weapons-grade material or non-weapons-grade material. It's my understanding that for nuclear space propulsion, you have settled on low-enriched, non-weapons usable And that's correct, yeah.
That's what we
Correct.
currently use. Yes.
And on the other hand, it appears you're not heading in that direction, at least initially, for space power reactors. These are things that would be used for potentially on satellites, potentially on lunar or Mars bases.
Sure.
And, you know, a future where every spacefaring nation has a big inventory of weapons-grade material to service the reactors that they are using all over the moon and all over Mars is not a very safe space environment. And you know, I've spent some time looking into it. There will be some small performance compromises in going with low-enriched, non-weapons grade material. But I really urge you to look hard at keeping alive the prospect of having an international collaboration to develop workable, non-weapons grade based materials that the whole world will use. And
I will look at those options.
thank you, I appreciate
You
it.
bet.
Thank you very much. Mr. Cloud.
Hello.
Oh, hey.
Way over
there you
here.
are.
Good to see you.
Good to see you.
Thanks for being here. You certainly probably have the funnest job in the room.
I agree.
And it's certainly exciting what's going on in space right now. Not only is it exciting, it's necessary and noble, the work that's being done. NASA certainly is part of our national heritage, and what's going on is necessary. This renewed space race is certainly essential, not only from the exploratory side of science and those kind of things, but from the national security standpoint, when we see China and all they're doing to take the high ground, and in an information economy, who controls space controls the information, and it's just essential, of course, that we continue to lead in that front. My question has to do with you inherited, if you talk to GAO, or the Government Accountability Office, sorry, I got that backwards, GAO, they have NASA on the high risk for waste, and have actually downgraded them. Now, this is what you walked into. I'm wondering what we're doing, because as we prioritize how important it is to spend the certain levels of money, I think it's just as important that we prioritize the efficiencies. Can you speak to what NASA's doing to create efficiencies, and especially, you know, in the sense of being more efficient than China and in winning the space race, the new space race?
Absolutely. So you're absolutely right. The GAO high-risk list has NASA on it, and yes, we have been downgraded. So the reason we're there is because we have not been good at maintaining schedule, and we have not been good at maintaining cost. Now, there's a number of reasons for that, and I think people on this committee are well aware. What we do is unique. It's unlike anything that any other agency does. We build things that have never existed before, and we have to invent things to make our products work, things that are really, quite frankly, astonishing and stunning. So I'm not making any kind of excuse. We need to be much better at making determinations as to the cost of what we're going to build and the schedule of what we're going to build. Part of that requires us to ultimately not be so aggressive in what we say we can achieve. We need to make sure that we have margin built into our schedules and into our costs, as a matter of fact. NASA is very ambitious as an agency. It's a culture that, in fact, it's a kind of a good thing. Everybody wants to work really hard to achieve just amazing and astonishing things and do it yesterday. But sometimes we need to be more realistic, and that's part of what we're trying to get fixed. When we have schedule delays, whether it's commercial crew or SLS or exploration upper stage, whatever the case might be, those delays ultimately it puts us as an agency at risk, and it encourages congressmen to ask questions that we don't like to answer. So we've got to get better at making those assessments, and we're working on that.
I think of, for example, there's an Israeli space company landing, or that in the next few weeks we think will land on the moon, the first commercial company. What's going on in the commercial industry? Can you speak to ways that NASA's partnering with it? Maybe
absolutely.
Is that one way to save money? And also, For example, the X Prize, that Israeli company was motivated by an X Prize. Is NASA doing that kind of thing when it comes to contracting to maybe take the burden of research off some of these things and put it in the innovators?
Yes, here's the challenge. Sometimes the companies have an incentive to overstate what they can achieve as well, because they're all trying to win contracts in that particular case. So we have to be careful about, in other words, we as an agency not only need to be good at managing our own programs, but we have to be really good buyers. We have to be smart buyers. And in fact, I would argue that it could be said that as we have turned more to commercial industry to provide capability, we have lost, in some cases, the intellectual capital necessary to be a smart buyer. So on one hand, yes, you're right, we can outsource some of those challenges. On the other hand, we still have to meet schedule and we still have to meet cost. And we can't rely on somebody else to tell us what that schedule and cost is, because sometimes they're not right either, and then we're held accountable for it. So we have to be careful with how we go about that in the future. But the X Prize, you mentioned Space IL. We are partnering with Space IL, which is that little Israeli company. They're going to be landing something on the moon for $95 million worth of investment, which is a radical change in cost for anything that's ever landed on the moon previously. NASA is a partner with them on an instrument that's on that vehicle. We are also providing our deep space network to support them with communications, which is unique to us. So we're a partner with them. We're proud of that. And we have our own program domestically for commercial lunar payload services, where we have already signed up 9 companies that we have assessed are able to deliver small payloads to the surface of the moon. And we're looking forward to, in fact, we have already put out the first task order, and we're looking forward to seeing what industry is going to be willing to provide from a domestic perspective as far as landing small payloads on the surface of the moon. All of these things are critical capabilities, and in some cases they help us with the GAO high-risk report. In other cases, it could actually put us in more risk, but we have to be more careful about how we go about telling you and others about our schedule. As much as we want to tell everybody we're going to get there yesterday, we need to be really careful about that. Thank you.
Thank you very much. Mr. McAdams.
Thank you, Madam Chair, and thank you, Administrator Bridenstine, for your time and for your testimony to the committee here today. NASA enjoys an incredible reputation with the American people, and and with myself as well. And I'm excited to hear more about the inspiring plans for the future of our nation's space program. It's been an interesting and informative dialogue today. Utah, my home state, has a proud heritage of supporting human space exploration as well, from the building of the reusable solid rocket motors that boosted the space shuttle's 135 launches from 1981 through 2011, to the updated versions being produced for the Space Launch System, or SLS, to take us back to the moon and beyond, as we've been discussing today. I also believe that I share with you the belief that we must ensure our priorities are informed by the scientific community's knowledge and priorities for exploration and technology development, and that our goals, which certainly must be ambitious as they are also grounded in our ability to deliver the requisite technology and safely complete the mission. So my question for you is, first of all, I guess I'm a little perplexed that after NASA prepared the agency's budget request, the administration announced the acceleration of the plans to send humans to the moon again by 2024, rather than the previous goal, a goal that I support. And while I think that objective is laudable, I'm concerned that given what appears to be a lack of planning for such a goal, that NASA still has a lot of questions to answer to achieve that mission on such a short time frame. So I'm also pleased to hear your ongoing commitment to the SLS, but how would this budget speed up SLS development and readiness, particularly in light of its important role in the accelerated mission schedule?
So the budget request currently has us focused on the core stage of SLS, which is where the challenge has been, specifically the engine section on that core stage. And so we are using the resources that we have for the SLS focused on that. And we have in fact made tooling investments so that we can integrate the oxygen tank, the inner tank, the hydrogen tank in a horizontal way. So the engine section is no longer in the critical path, and we can continue assembling the rest of the rocket for a delivery by the end of this year. So all of that, I think, is progress in the right direction. And you had a question ahead of that. What was the?
Yeah, just how in light of the enroll, how, sorry, let me just look back at my notes here.
Yeah.
Well, I guess a follow-on question that I would has this accelerated schedule, have you discussed that with the Aerospace Safety Advisory Panel, and what comments or concerns did they have, if any?
So that's the answer is that we have discussed this. I had a town hall yesterday. We got questions about it with the entire NASA family, and put it all out there and said, look, we have a new agenda to get there in 2024. And of course, there were questions like, are we going to compromise safety? And the answer is, Congressman, absolutely not. We have independent technical authorities embedded into the programs. Those independent technical authorities, you know, they don't get their assessment from their manager, does not come from the program. It's completely independent. And if they need to throw a red flag and say this isn't safe, they have a job to do that. And we want those independent technical authorities for safety to stay in place, whether it's engineering or technology or, you know, human factors, medicine. All of those safety valves are in place and they're strong, and we're gonna keep them. We're not gonna take any undue risk. But I would like to say, when John F. Kennedy announced we were going to the moon, in Congress, as a matter of fact, in 1961, it was only weeks after Alan Shepard passed the Kármán line. It was basically a very short hop straight up and straight down. And in a matter of weeks, he was announcing, we're going to go to the moon by the end of the decade. That was a moment in American history that was transformative. It captured the imagination of the American people. It wasn't without challenges, but we achieved it. And now it's an accomplishment that everybody still quotes. Everybody still talks about. My children watch the videos, and I'm sure your family has as well. Yeah. So all of these things, I think, are important. Like, this is, in my view, this is a great opportunity for this agency. It's a great opportunity for the country, and I think we can capitalize on it.
Thank you, Mr. Administrator. Applaud the ambition. Let's make sure we do it safely.
Yes, sir.
I yield back.
Thank you very much, Mr. Olson.
I thank the chair and welcome to a former member of this committee, a former naval aviator, and a fellow Rice University graduate.
Go Owls.
Go Owls.
Hoot.
Before I ask you questions, I'm compelled to make some comments on Vice President Pence's vision of going to the moon in 5 years. We all know NASA's attitude from Apollo 13. Failure is not an option. But listening to my colleagues from their side of the aisle, that phrase may now be, failure is the only option. I remind my colleagues, the young president, John Fitzgerald Kennedy, told the American people at our alma mater, Rice University, and this is a quote, "I realize that this is in some measure an act of faith and vision," end quote. "We choose to go to the moon in this decade." He said that on September 12th of 1962. Neil Armstrong said, "That's one small step for man, a giant leap for mankind," 6 years and 311 days after that inspiring speech. We can go back to the moon if we make the commitment in 5 years. And I think to go to Mars, we have to go back to the moon first. The moon should be the place we train for going to Mars. A few examples. The moon's gravity is 1/6 of our gravity. Mars is 1/3. You talk to Neil Armstrong, I did before he passed on, or Buzz Aldrin. They tried to walk on the moon. Within minutes, they learned how to hop to get around. My point is, we have a great pool by the Johnson Space Center. They can train there, but it's not actually working in the atmosphere of the gravity we have between Mars and the moon. We have one difference, too, about going to the moon in the 60s and days. We have the rocket being built right now, the SLS. It's going forward. It's online. It may be ready to fly in the next couple of years. The Saturn V came out of nowhere to go flying. We're way ahead of the curve on that one. We have the crew vehicle. This committee saved the Orion capsule when it was killed with the previous administration's destruction of the Constellation project. We saved that capsule to take human beings, Americans, back to the moon, to Mars, and beyond. It's been mentioned too, we have to have bigger rockets to go to Mars, faster rockets. Right now, the moon is about 2 days away with our current rockets. Jim can tell you Mars is probably 3 months, 4 months, 6 months?
7, maybe.
7 months.
Yeah.
That means people have to have food, they have to have water supplies. That's going to be one big, heavy rocket. Have to have new propulsion system. For example, former astronaut named Franklin Chang Diaz has what's called it's draw a blank on here, but it's basically a rocket. It keeps accelerating. Jim was reminding me what the rocket's called, but it goes faster and faster. Not the speed of sound, but the speed of light. Maybe get to Mars within 3 weeks as opposed to 3 months. Also, there's a big belt of radiation between Earth and Mars. We've never been through that with humans. We have to learn how we get through that band and keep humans alive. So my question to you, my good colleague, Administrator Bridenstine, do you think going to the moon helps us get to Mars?
Without question. In fact, I would argue you cannot get to Mars unless you use the moon as a tool to get there. What I'm talking about is we need to learn to live and work on another world. You don't want to try that for the first time when it's going to take 7 months to get home. And by the way, you've got to be there for 2 years before you try to come home because the Earth and the moon are not going to be on the same side of the sun. So the moon is the proving ground. We have to learn to live and work on another world. We've proven, going back to Apollo 13, we have proven that you can come home safely when something goes wrong during a moon mission. If we were to do that on the way to Mars, it would be devastating.
And recall Franklin Chang Diaz rocket's called the plasma rocket. Basically goes faster and faster and faster. One question about China.
Yeah.
As you know, Apollo 11 left a plaque on the moon that said, the last line was, "We came in peace for all mankind." I guarantee you, if that's China put a plaque on the moon, it'll say something like, "We came to make the moon ours." Look no further than right here on Earth, the South China Sea. China has torn apart pristine reefs, 6 of them, to make bases out of them. Do we think they'll change their attitude going to the moon as opposed to what they're doing here on Earth? Or should we ramp this up and go to the moon ASAP?
You're asking me?
I'm asking you, yes, sir.
Well, I think we should go ASAP. But it's also true, just as you identified, when you talk about a plasma rocket, the idea is when you think about a rocket, you've got 2 things. You've got mass that comes out of the back end of the rocket, and you've got how fast that mass is going. What Franklin Chang Diaz is doing is he's accelerating subatomic particles, electrons, as you mentioned, at close to the speed of light. And so when you talk about the mass being that small, that means the acceleration has to be that fast, which is why that would be a capability. That would be, I know earlier Congressman Foster was talking about nuclear capabilities. That would be nuclear electric propulsion, which would be an absolute game changer. Getting to Mars in a matter of weeks rather than a matter of months would be transformational and enable us to do more, and it would protect human lives. So we are making investments in that. In fact, those investments are in this budget and would be 100% transformational.
Thank you. Time. I close by saying, go Navy, beat Army.
Go Navy.
Thank you very much, Mr. Caston.
Thank you, Chairwoman Johnson. Thank you, Administrator Bridenstine. In 2009, the National Academies published the study America's Future in Space, aligning the civil space program with national needs. And among other things, it said, quote, NASA and NOAA should lead the formation of an international satellite observing architecture capable of monitoring global climate change and its consequences. Congresswoman Bonamici also brought up the 2018 Earth Science Decadal Survey, which prioritized the measurements that would be taken from 2 missions, the PACE mission that she mentioned, and the Clario Pathfinder mission. Both of those missions, I think, are widely regarded as crucial in helping us measure how our climate is changing and to plan mitigation and adaptation policies. Now, we've already mentioned that that's been curtailed in the President's budget. I think it's worth reminding that those were cut in the last 2 budgets from the administration. Those programs exist today not because of the administration, but because Congress insisted on keeping those programs going.
And we are, sir, keeping those programs going, and we're moving rapidly to get those programs online.
Well, but as you've mentioned, they're being curtailed now because of the changes that you're putting in place. And so you had mentioned that there was a budgetary pressure to terminate those missions. In your earlier comments, was there any scientific basis for terminating those missions?
There indeed was. Clario Pathfinder is a technology demonstrator to be on the International Space Station. It ultimately is basically a radiation budget instrument that we have other instruments in orbit right now that are measuring the radiation budget of the Earth. In other words, energy comes in from the sun. It's in optical parts of the electromagnetic spectrum and other parts of the electromagnetic spectrum. And then when that energy dissipates, it's in infrared. And so we're measuring the total, basically, radiation budget of the Earth so that we can monitor climate change. And we're doing that not just with Clario Pathfinder, which is simply a technology demonstrator. We're doing it with missions that are already on orbit.
Well, if I could ask you, please, to submit to the committee a specific list of those missions that are going to provide the information that we're losing.
Absolutely.
In that. And, I guess I'd also like to know, you'd mentioned that you had some consensus from the scientific community. Can you provide specifically who in the scientific community has confirmed that cutting those missions will not interfere with our ability to understand how our climate is changing and what we need to do to adapt?
I can provide you with that.
Okay. Well, it seems to me that the budget that you're proposing has a sense that exploration should be the primary mission of NASA rather than understanding the one planet in the universe that we know actually has the capability to accommodate human life. There is cutting in this program for out-year programs. We've got funding right now for studying the Earth, but cutting in out-year programs. And under these scenarios, if I'm following the math, NASA's not going to be initiating any new high-priority decadal missions over the 5-year budget horizon, which leaves the possibility for a gap with no priority strategic missions underway, and would cut Earth science in FY2020. Given all that, and this is just a yes or no question, do you personally believe that anthropogenic global warming is real and happening?
Absolutely, I do. As a matter of fact, carbon dioxide is a greenhouse gas. We've put more of it into the atmosphere than ever before, and it is, in fact, causing the climate to change. And by the way, we're studying every day. In fact, we're launching here in a month the Orbital Carbon Observatory 3, which was cut in the last budget request, but not in this budget request.
So do you believe that we currently have the tools to meet the recommendation of the National Academies that NASA and NOAA should lead the formation of an international satellite observing architecture capable of monitoring global climate change and its consequences?
I absolutely do. Just to be clear, Congressman, this budget request is higher than 5 of the budgets under President Obama for Earth science specifically.
But we're cutting the programs that I think are. We'll find out when we see your submission coming back. What do you think are the chances? I have a real fear that we may have a century left that this planet is truly habitable, particularly on our coastlines and runaway temperatures and melting permafrost. What do you think are the chances if we run into a situation in the next century where this planet is not as habitable as we'd like it to be, that we have the ability to escape Earth and live on another planet?
Well, that's I don't really have any way of answering that question.
Would you say it's greater than 1%?
Within how many years?
Within a century. Do you say it's greater than 1%?
You're talking about moving humanity off Earth to another planet. I'm not banking on that.
So then how do you justify over-prioritizing exploration at the expense of understanding the planet we have?
So I think what exploration does is it inspires the nation. We go back to the Apollo era and we look at everything that came from the Apollo era. I hear about Tang and I hear about Velcro, but what we're talking about is communication architectures. So the way many people probably listening right now watch DirecTV or Dish Network. Maybe they listen to XM radio. Maybe they get their internet broadband, as many of my former constituents from Oklahoma, they get their internet from space. Like, all of those communication architectures were born from an idea that we should go to the moon back in the 1960s.
I think I'm out of time, but I'm all for inspiration of future generations. I just want to make sure that we have future generations. Thank you.
Yes, sir.
Thank you very much, Mr. Beard.
Thank you, Madam Chair. Mr. Bridenstine, we appreciate you being here. You know, space exploration is certainly exciting in its own right. And then finding the tons of frozen water on the moon certainly adds to its intrigue as far as a stepping stone to going to Mars. And I think it's interesting that the frozen water can not only furnish water, but it can furnish fuel and hydrogen and oxygen and so on. So very interesting. Purdue University's in my district, and as you know, we've produced 24 astronauts. Among those is Neil Armstrong, Gus Grissom, Lauren Shriver. Purdue has a long history in space and aeronautics innovation. The National Defense Industrial Association is hosting a conference at Purdue University over the summer on the topic of hypersonics. So in that vein, can you give us any more detail about NASA's plan to invest in the hypersonic technology? What you think?
Absolutely. So this is a part of our portfolio, and it's an important part. We talk about, you know, what we do as an agency. We have to get through the atmosphere in order to go to space. Hypersonics are a piece of that. And in fact, we have a lot of the facilities and the capabilities that are resident within NASA that other agencies use for those capabilities as well, for testing and ultimately developing hypersonics. So we are a partner with other agencies at the same time. It's an important part of what we do.
Thank you. Can you also describe to the committee how NASA's partnership with universities like Purdue on cutting-edge research, and it may impact agriculture, and I have a tremendous interest in that as well.
That's it. Yes.
And
So go ahead.
No, I was just going to ask how this committee could be helpful in helping those partnerships grow. So,
great question. Number one, universities help us reach more of the country with the goodness that NASA delivers. I would say, just so you're aware, Purdue, the center director at the Johnson Space Center in Houston, is a Purdue graduate. The associate administrator of the Human Exploration and Operations Mission Directorate here in Washington, D.C. is a Purdue graduate. And forget about the 24 astronauts, they're littered throughout all of NASA. So you should be proud of this university that's in your district. Going back to the ag piece, and I think this goes to Representative Kasten's question as well about what NASA does and why earth science is so important. Climate change is a big piece of what we do. We're the only agency that does it, and we do more of it than any other nation in the world by far, and that's a good thing. What we're learning now is from the earth science capabilities that have been delivered for purposes that weren't focused on agriculture, we're actually now applying that capability to do a number of things, including increasing crop yields, while reducing water usage. We've got a partnership with, going back to the university question you asked, sir, partnership with the University of California Cooperative Extension. And what they're demonstrating is that with our remote sensing from space of the agriculture communities in California, we are increasing crop yields while reducing water usage by 25%, which means that water is now available for rivers and reservoirs and other areas. We're potentially, in fact, saving species that are at risk. And at the same time, we're feeding more of the community than we otherwise would have fed. So crop yields are going up 25%, water usage is down about 25%, and at the same time, we're preserving the nitrates in the soil. So normally, when you overwater, those nitrates erode away. And there's two problems there. Number one, the plants don't have them, which is why the crop yields aren't as high. And number two, it ends up in the water that humans drink, which costs millions and millions of dollars to clean. So the goodness that is coming from the earth science budget of NASA has a lot of application. Now, we're just scraping the surface with these cooperative extensions, with this cooperative extension of the University of California. The goal is to expand this, in fact, nationwide and then worldwide. In 2017, NASA was able to predict a severe drought in Uganda in 2017. And because of that, we were able to mitigate a disaster with millions of dollars from the American taxpayer dollar, but it prevented the natural disaster that would have cost dozens of millions of dollars. So we not only saved lives, we saved American taxpayer dollars because of this capability that we have resident in the Earth Science Division of the Science Mission Directorate.
Thank you very much. I'm very glad to hear that. I yield back.
Thank you very much. Mr. Byer. Mr. Cohn.
Thank you, Madam Chair. And I would just like to ask a couple of questions. Firstly, I was all concerned when we decided to use Russia for all of our launches many years ago. Apparently that's worked. We haven't lost anybody yet, although there was one
Yes, sir.
didn't do too well. When are we going to have our own flights? And when we do, what will the Russia program be? Will we have it as a secondary option or what?
Great question, and it's something that we need to start really communicating. I think it's an important issue. Yes, this year, we believe we're going to have 2 commercial crew providers that enable us to launch our astronauts from American soil to the International Space Station. The goal here, though, is not to replace our partnership with Russia. The International Space Station has proven to be an amazing capability, a channel of communication with a country that, as you're aware, we have all kinds of terrestrial disputes, but since the 1990s, we've been able to collaborate on the International Space Station. And even before that, if you go back to the Shuttle Mir program, and even before that, if you go back to Apollo Soyuz, height of the Cold War, we have, as a nation, been able to cooperate in space. They have amazing capabilities. We can take advantage of that. We have amazing capabilities that they can take advantage of for science and exploration and discovery. We want to make sure that when we do have our own capability, that they can launch on our rockets and we can launch on their rockets. So the partnership continues. It's just more of a partnership rather than us purchasing seats from them as a customer. It would be more of a partnership. In other words, a no exchange of funds kind of bilateral partnership for access to low Earth orbit.
So once we get our rockets going and get us to move, we will not be using the Russians so much.
It'll be a partnership. It'll be a partnership rather than a dependency.
And you feel confident that they're, I mean, I don't think they've lost anybody in space yet, have they?
Not since we've been dependent on them for our access to the International Space Station. We had one rocket that we launched back in October, but because of their design, they were able to eject their crew module, and everybody came home safely.
Going to the moon and going to Mars, is that what every other country has as their line, first moon and then the Mars?
Well, I will tell you, we're unique in that we have the capability to deliver this opportunity. I will tell you that every country, the head of every agency that I've met with is very excited about going to the moon, and they're looking forward to partnering with us. This is really American leadership at its finest. There is just a lot of excitement all around the world to partner with us on this.
What has China done? Did they go around once? Did they send some?
They have had a number of landers on the surface of the moon. They currently have Chang'e 4 on the far side of the moon.
But no people?
They've never had a person on the moon.
All right, but China wants to do that, obviously.
They do.
And then after that, is there a plan to go to Mars, or do they have a plan beyond that?
I don't know that they have a plan to go to Mars at this point.
Okay. You were talking about supersonic flight.
Yes, sir.
And quick research, Boom and Boeing are both kind of looking into this as private. What's NASA's role in this?
That's a great question. So what we do is we prove capability, we prove technology, we retire risk, and our goal is always to commercialize, to license, to give other people the capability of advancing their technologies or using our technologies to their benefit. The intent being that it enables the United States of America to remain a leader in this very high technological field of aerospace, and then increase exports. That's the role that we play. We do not want to compete with private sector. We partner with the private sector so that they can actually achieve more in the international community.
And is the Concorde coming back?
Well, the low boom flight demonstrator is not the Concorde, but it will. The Concorde, it created a very loud boom.
Yeah.
And that's why it couldn't fly over the United States. It only flew over the ocean. What we're trying to do is something entirely different, where we could have a supersonic aircraft fly over the United States, and the boom would be insignificant.
But is I thought I read somewhere the Concorde, British, French, they were going to start to do flights again over the ocean.
I don't know about the Concorde. I do know that there's a lot of companies that are interested, all over the world, interested in supersonic flight again.
And then let me ask you about the space suits that were not
Yes, sir.
for women. You had one that could fit a woman. You didn't have two. I know it's Saturday Night Live and all, but still, you'd have suits for dogs and monkeys and another woman.
So we did have 2 spacesuits for 2 women, and the challenge is each spacesuit is not. Think of it as a spacecraft. That's what it is. It's a spacecraft that goes outside the International Space Station, and they're designed not just for the person, but for the specific mission. Our astronaut, Anne McLean, made a determination that in the interest of crew success, that she thought it would be better to change the spacewalk person rather than to modify the spacesuit. We as NASA, we had an option to modify the spacesuit. We made a she made the call that it was better to not modify, which would take hours and inject risk. She made a determination that it would be better to change the crew rather than the suit. And just so you know, sir, we are making sure that in the future, both genders are going to be accommodated 100%.
And let me close just by saying, I've been very impressed with your presentation and feel comfortable about your being at NASA, and thank you for doing this. And I think we do need to get as quickly to we can, I guess, to the moon, and et cetera. But just keep in your mind the whole time you're being told to speed it up, the O-rings.
Yes, sir.
You know, I think there was quite a bit of suspicion that the politics said get that flying regardless, and the O-rings. So
absolutely.
Thank you very much, Mr. Weber.
Thank you, Madam. Administrator, welcome back.
Thank you. Great to be here.
Glad to see you here.
Always.
You went to Rice University, and of
Can
course,
you imagine?
I know. Well, we'll welcome you back to Texas to spend lots of money anytime. Of course, that's where our great President JFK made his pronouncement. We choose to go to the moon, not because it's easy, but because it's hard. And refresh my memory, Jim, if you don't mind me calling you that. How long did it take us to get to the moon at that point?
See, he made the announcement in Congress in 1961. He made the announcement at Rice University in 1962, and we had boots on the moon on July 20th, 1969.
And I know there was people back then, to use that phrase, hot air, that a lot of people thought that was hot air. But in reality, we actually got that job done. It was 7 years, give or take, right? And would you characterize that? I know you're a little bit of a student of history. That was before your time. You were born in 75?
I was born, yes. I'm the first NASA administrator that was not alive when we had people on the moon.
Well, you're doing a fine job.
Thank you.
So that was 7 years. Would you characterize that as uncharted territory?
A little bit.
A little bit, absolutely. Is it fair to say that we had less computing power back then than we currently have?
Slightly.
A little bit. Did we have less funding back then than we have now?
Actually, no. We had a lot more funding.
Is that right? So percentage-wise, we were good on funding.
In 2014 dollars, at our peak, it was in 2014 dollars.
Right.
It was about $40 billion annually was NASA's budget, and so today it would be, about 20 billion.
So you could say that was a sign of how important what a priority it was for us.
It was a high priority.
Absolutely, it was high priority. Did we have less technology back then than we have today?
A lot less.
A lot less. So some would say, did we have less belief and faith that we could do it back then?
I guess you could make that argument.
I know you weren't on the earth here at that point, but I can tell you there was a lot of people thought we'd never get it done. In your being a student of history and being so involved in NASA, and I so appreciate you, on behalf of the 17,000 employees, by the way, thank you for being here and what you're doing. Have you seen any other president announce 4 national space objectives?
Not in this way, not anywhere near this level of commitment with these really very impressive goals.
Right, absolutely. So you're, based on what we were just talking about, you know, less technology, less computing power, a lot of people didn't know if we would be able to make it. You have confidence that we can hit that 5 years.
I believe it can be done.
Yeah, I would agree with you, say that what we have right now in NASA, what a fine organization. If it is our priority, if we double down to get it done, we're going to get her done. And we do. I would argue that most of us on the Science Committee believe we're going to get it done too. So I thank you for that confidence. I want to say a couple things about it. You talked about there's a lot of good things that come out of NASA. In the discussion between you and Congresswoman Horn, you talked about a realm of possibility. I love that phrase. There's so many things that are within our realm of possibility, and NASA is leading the way on that. Don't you agree?
Agree completely.
And I was listening to you all talk, and I was also listening to you talk about the reduction gear that had been developed by NASA for airplanes, where it's flat on the bottom so that when they land, explain that again.
Oh, I was just looking at the nacelles of an engine not too long ago, and I noticed that it flattens out at the bottom. But the reason it was flattening out is because the nacelles keep getting bigger and bigger.
Yeah.
And the question is, I didn't know why, but I learned that it's because of technology that NASA developed that, in conjunction with our commercial partners, to improve the fuel efficiency and the environmental, I guess, mitigation efforts of our industry, so that we can improve exports for the United States of America.
Absolutely. Was glad to hear your exchange about the climate change thing. America ought to be in the leadership. We ought to be developing that technology, and NASA can lead the way.
And we have, yes.
You betcha. Glad to hear that. And I'll just say this: we're looking at one space directive of 4 right now.
Yeah.
Just one.
That's right.
And I will say that it's visionary. And Madam Chair, if I can be so bold as to say you love hearing about STEM, this is going to help our STEM program because it is visionary. I will say it's invigorating. Ma'am, we do need STEM to get there. Thank you for pointing that out. It's invigorating. You're going to see Americans get behind this, I believe, much as they did in 1961 and 62. I hope we're going to see bipartisanship out of this. I think we're going to see America get behind it, youth and STEM, as the chairwoman so appropriately pointed out. And look, I would argue that this is about American exceptionalism. Administrator Bridenstine, you made the comment that America needs to lead the way. And I will say that's exactly what's going to happen. It's going to be American exceptionalism. It's going to help STEM. It's going to help inspire, especially in the STEM, back to STEM. And I can't go any much further because I'm out of time. Do you see any reason why we shouldn't go forward with this?
I think we absolutely need to.
I think you're on track, Jim. Thanks a lot.
Thank you.
Thank you very much. Mr. Byer.
Madam Chair, thank you very much. Administrator, welcome.
Thank you.
Like many of my colleagues, I was disappointed to see that the President's budget request for 2020 has many of the same cuts to NASA science, education, earth science programs that it did last year. Even after Congress, basically stood many of them up. Eliminating NASA's key STEM programs, PACE, Clario, they seem short-sighted, and we need to continue investing in both our generation and climate research. But the appropriations process will work a lot of that out, I know. I am very excited about off to the moon and off to Mars. This is really exciting stuff. But the trade-off that I'm really concerned with is eliminating the highest ranked priority of the Decade survey, which is WFIRST, the Wide Field Infrared Survey Telescope. When Commissioner Bolden was here a couple of years ago, I think you were sitting on the committee at the time, I asked him, NASA's constancy of purpose, what should it be? And he, without hesitation, he said science. And the most fundamental, essential science we have right now is trying to figure out about dark energy, about what's happening in the origin of the universe with the infrared stuff, all the exoplanets. And I think initially, James Webb, that you're very committed to, and WFIRST were planned together. They were going to complement each other. So why does it make any sense to take WFIRST out of our budget? And how can we, and isn't this going to jeopardize that project in the long run and diminish what we can get from James Webb?
It's a wonderful question, Congressman, and the way I would answer it is the James Webb Space Telescope is really our biggest flagship mission in the Astrophysics Division of the Science Mission Directorate, and we're committed to it. We have to be committed to it. By the time this is over, March of 2021, we're going to launch it. We're going to be $9 billion into that program. The challenge is, and this goes back to an earlier question about maintaining schedule and maintaining cost. When I first came in, that program was being pushed back and the cost was increased. I had to come back to this committee to get authorization to, in fact, go forward with this mission given the cost increase and the schedule delay. All of that being said, when we have a flagship mission like that goes well beyond what we ever envisioned, it ends up impacting other missions within the Astrophysics Division. So I think as we go forward, what we have to consider, and what I'm hoping to work with you on, is a balanced portfolio. We certainly want to do flagship missions, but when we have a flagship mission like this that goes over, and then we're on the brink of starting another flagship mission, the only way to do that would be to cannibalize a lot of smaller class missions, medium class missions, and when we do that activity, then we put a lot more risk on the entire Astrophysics Division. So we have to get smarter, I think, in the future of creating a more balanced portfolio. And you're absolutely right. The W first is to work with James Webb. It's important that we get James Webb into space because ultimately, to the extent that we ever have W first available to us, it needs to work in conjunction with James Webb. If James Webb doesn't launch, then W first is not going to be as useful, although it would be tremendously valuable.
Well, please count on us to continue to press on W first in the years to come from the Science Committee.
You bet.
I'm sure you've seen the charts that show the percentage of our federal budget or percentage of GDP that the NASA budget was back when we were going to the moon.
Yes.
And now we're going to go again and to Mars. You talked about the $40 billion in today's numbers, 2014.
Yeah.
Realistically, how do you expect to be able to do this when our NASA budget's a fraction of what it was before?
It's a great question. To start, we're making assessments right now as to if we're going to land in 2024, which we're going to do. The question is, how do we achieve that? And we're going to be coming back with a budget amendment. Number two, it's also true that we have more capabilities right now, and I think Congressman Weber hit on a lot of these. We have the miniaturization of electronics. We have reusable launch vehicles. We have commercial launch vehicles. We have a lot of the hardware that exists right now that didn't exist in 1961 and in 1962 when President Kennedy made his famous speeches. All of those capabilities collude to say that we have an opportunity here, should we choose to accept it, to no kidding get to the moon in 2024. That kind of vision is in front of us if we want to go after it. And I think we can achieve it given what is available right now. And don't get me wrong, it's not going to be without additional resources. But the key in order to get that, of course, is bipartisan consensus. And I understand that, and I'm working towards that.
Great. Thank you very much.
You bet.
Madam Chair, I yield back.
Thank you very much, Mr. Babb.
Yes, ma'am. Thank you very much, Madam Chair. Good to see you there, Mr. Administrator.
Good to see you.
Appreciate all the great work you're doing. I proudly represent the Johnson Space Center in Houston, which manages the International Space Station, the Lunar Gateway program, and development of the next generation spacesuits. And I understand that NASA is currently undergoing a study to evaluate the cost of returning to the moon, as we've been speaking about this morning. JSC stands ready to execute the Vice President's very exciting vision to return to the moon as soon as possible. So I wanted to ask you just a few questions. How much will it cost to complete the Lunar Gateway as proposed in the FY20 budget request?
So there's a number of issues. When we go to the moon in 2024, in order to achieve that, we have to accelerate the gateway process. We need a power and propulsion element, and we need a habitation module. We need to be able to forward stage, if you will, landing capability, so that when we launch humans in 2024, they have the tools necessary to get to the surface of the moon. So all of those right now are in flux, and it's important for me in the coming weeks to come back to you with what that cost is going to look like.
Okay, I got you. What impact will accelerating exploration of the moon have on the International Space Station?
It shouldn't have any impact on the International Space Station. Low Earth orbit is still key to our mission, and it should have no impact.
Okay, great. How much will it cost to accelerate lunar lander development? I guess you'll have to get back with us on that as well.
Yes, sir, I'd appreciate that.
Okay. Our current spacesuits were developed in the late 70s. Recent EVA issues have highlighted NASA challenges with spacesuits. After losing suits in the Challenger, Columbia, and SpaceX cargo accidents, we only have a handful left in inventory. Over the last several years, astronauts have even almost drowned in their spacesuits. The current spacesuits used on ISS are not capable of surface operations. NASA issued a report to Congress that laid out a plan for future spacesuit development. Will that plan be accelerated now that we're accelerating exploration of the moon's surface?
Sir, in order to get to the moon's surface, we have to have new spacesuits.
Okay.
It's going to can't.
It's a no-brainer.
Yes.
Yeah. Okay. And what do you expect that cost to be? And will GSC maintain its role in spacesuit development?
The astronaut office at JSC will absolutely be involved, and their role is not going to change. Certainly the cost is something I'm going to have to get back to you on.
Okay. And as I said earlier, the American public is excited by the administration's enthusiasm for space exploration, and I certainly look forward to helping achieve all of these very, very exciting goals. And then I think I've got a little time left. Last month, the chairwoman and ranking member sent a letter to the commissioners of the FCC expressing concern about its proposed radio frequency spectrum auction. Based on feedback from the scientific community, their letter highlighted the need for interagency consultation among affected scientific agencies and the consideration of unintended consequences on areas such as weather forecasting before the auction could move forward. Can you explain to the committee what NASA's role is during the interagency consultation process and concerns that you have about last month's auctions?
A great question. So NASA works with the NTIA, which is the government arbiter of spectrum issues, and NTIA ultimately represents NASA to the rest of the government when it comes to spectrum auctions and that kind of thing. I will tell you that the 24 gigahertz spectrum that is being auctioned could have an impact on NASA's missions. When we talk about sensing the Earth in the 23 gigahertz range, what that enables us to do is characterize water vapor in the atmosphere. It enables us to characterize energy in the atmosphere. And why is that important? Because that's how we're able to make predictions. I say we, NASA is not responsible for the operational capabilities, but we are responsible for developing the satellites for NOAA that operates them operationally. And that part of the electromagnetic spectrum is necessary to make predictions as to where a hurricane is going to make landfall. So that has a big impact. If you can't make that prediction accurately, then you end up not evacuating the right people, and or you evacuate people that don't need to evacuate, which is a problem. And all those have impact. When it comes to Hurricane Sandy, for example, the United States of America believed it was going to be heading out to sea. The European model got it right. Well, it wasn't the European model, it was the European data. They had better data than we had from their systems. We want to make sure we get this right because it's necessary to life and property. It's also important to recognize when it comes to weather forecasting in general. Again, you'd have to ask NOAA, but my consultations with them, we're talking about going back to 1978 levels of data. In other words, instead of a 7-day weather forecast, a 2 or a 3-day weather forecast. Again, I'm not saying that they sold our spectrum. That didn't happen. But there is a risk that depending on the power and the position of the cell towers in the 5G network, it could bleed over into our spectrum, and that's the risk. And the assessments that NASA has done in conjunction with NOAA have determined that there is a very high probability that we are going to lose a lot of data.
A lot of challenges there, Mr. Administrator. I want to thank you for your hard work and your insight and experience, and I'm looking forward to helping achieve the goals that you've laid out for us today, and and still at the same time be a good steward of the taxpayers' funds.
Yes, sir.
I'll yield back.
Thank you very
Thank you.
much. Ms. Stevens.
Thank you. Administrator Bridenstine, on March 27th, our House Speaker, in partnership with our fabulous chairwoman, had a reception commemorating the 50th anniversary of landing on the moon in celebration with Women's History Month. It was held here on the Capitol and included the shining stars, the women in mathematicians of America's space program. Were you invited to that reception?
I'm not 100% sure.
And so I take it you did not attend?
I did not attend.
My colleague asked about the spacesuits, and I'm not sure you're aware that Christina Hammond Koch, who is a resident of, is originally from Michigan, where I represent, was intended to go on that.
But she does live in Galveston.
That's true, but Michigan was really quite excited to have Ms. Koch go on the trip, and she was not able to. Is it correct that no woman has ever been to the moon, sir?
That is correct.
And this was a part of 3 spacewalks that were supposed to have taken place. And I was wondering if you could extrapolate on those missions and what the intentions of those missions were. And because the 29th has since come and gone, who went on that mission and what is expected to take place?
So you're talking about the spacewalk?
Yeah.
On the 29th? It was Christina Koch and it was Nick Hague, and they were replacing batteries on the International Space Station.
And did the mission take place?
It did.
Okay, the walk?
Yes.
Okay. And Administrator Bridenstine, the budget proposal that we're discussing here today provides no funding for the Office of STEM Engagement, which includes the Minority University Research and Education Program, the National Space Grant, and on. These have been kind of longstanding initiatives, so just wondering, given what I was previously asking, why the administration, what the rationale was for cutting these programs and what you intend to do to support women in STEM and minorities in STEM.
Great question. So we support education initiatives for young people through the mission directorates at the agency. Earlier I was talking about one that I attended not too long ago, which was a FIRST robotics mission, or a FIRST robotics competition that I participated in. We support it with engineers, we support it with scientists, we encourage young people to get involved in the STEM fields. We do all of those things. We do the things, and by the way, the programs that you identified are currently funded, and we are using those programs. They're part of the President's Co-STEM initiative for STEM education, and we're continuing to advance those very important initiatives. It is also true that we want to direct resources where they can have the most impact for the agency and the most impact for the country. And in the budget request, we made a determination that some of these other missions for that activity are better. And in fact, if you talk to the folks that are building robots for Mars right now, they participated in FIRST Robotics. So that shows a direct return. And the folks that are doing FIRST Robotics now are interested in building robots for Mars or Pluto or Ultima Thule or wherever we may be going next, Bennu. So there's a lot of different opportunities there.
Well, you're obviously a significant leader, and we are so grateful for your service and your leadership of NASA. I know it was not easy during the shutdown with 95% of your workforce either not working or working without pay. And I'd like to invite you to exercise your leadership and join the chairwoman and I on occasion to sit down with STEM education groups. Black Girls Who Code is certainly very significant. Later today, I'm going to meet with a group called Tech Lady Mafia that has done a lot for women and the sciences. And we continue to encourage you to reconsider slashing those programs, and also would like to encourage you to support women in STEM and get that first woman on the moon for us, sir. Thank you.
Yes, ma'am, and I will say that in the speech that the Vice President gave last week, he was very clear that the next man and the first woman on the moon will both be Americans, and we look forward to that day. And I commit to you now that if you invite me to an event, I'll be happy to come.
Thank you.
You bet.
Thank you very much. Ms. Gonzalez Colon.
Thank you, Madam Chairwoman and Ranking Member Lucas, for actually welcoming me here. I'm honored to be part of this distinguished committee for the first time. I think I'm the first Puerto Rican representing the island in this committee, so I'm really excited to serve along my colleagues in this Science and Space Technology Committee. I look forward to represent a lot of the community in Puerto Rico. You may know that 42% of our economy runs on pharmaceutical manufacturing and electronic devices, and the bedrock for that is actually research and scientific investigations. On the other hand, we do have the Arecibo Observatory, which was the biggest radio telescope in the world for 50 years, second now just to China. So mainly been funded by the National Science Foundation and NASA through their program of grants. So having said that, my questions will be, first, I do notice that this budget in terms of the science area is $677 million more than to the one in fiscal year 2017. But I do have the concern that some of the programs, specifically the research and the area for space grants are supposed to be finished. So my first question will be specifically on that regard. How do we know that that kind of program that works with more than 150 network affiliates between colleges, universities, museum, and others consortia could be being restructured in the education activities it undertake and potentially canceling the National Space Grant College and Fellowship Program. I do know the need to economize, but I will love you to elaborate on those programs.
Sure. So NASA is very committed to STEM education. We're very committed to achieving better outcomes for the United States of America when it comes to producing the next generation scientist, technologist, engineer, and mathematician. And we do that through the various mission directorates, and we've found a lot of success in doing that. And we've made a determination through the budget request that the way we can make the most impact is in that way. And as far as Arecibo, I will say we're planning to spend about $4.5 million with Arecibo this year, and ramping up by 2022 about $5 million annually with Arecibo, which is a capability that we think is important and we currently utilize.
I'm really glad to hear that. As you may be aware, there's a lot of astonishing accomplishment of that observatory for the last 50, 60 years. Among them, many sites of pulsar, and people, even scientists that won the Nobel Prize for their research in that center. My second question will be in terms of, Puerto Rico was devastated by both hurricanes. Everybody knows that. Did the NASA receive all the allocated funds for the recovery of all the NASA facilities in the nation, including the tornadoes?
I will have to get back to you on that. I'm not 100% sure, but if I could take it for the record, I'll make sure I get you a correct answer.
Thank you. As you may be aware, that STEM technology and research is something that I will be pushing forward. So any way that we can help out and even work to establish more opportunities for kids in college to participate in those programs, I will be more than happy to work with. Having said that, I yield back the balance of my time.
Thank you, Congresswoman.
Thank you very much. Ms. Weston.
Thank you, Madam Chair, and thank you, Administrator, for joining us here today. I know a lot of my colleagues have already talked about the zeroing out of the STEM engagement in the President's proposed budget, and I echo those concerns. And in particular, I want to talk a little bit about the space grant program.
Okay.
Because I represent Virginia, and in Virginia, the program is able to leverage the funds that it gets from NASA to give high school students hands-on experience at Langley Research Center to work on real-life problems alongside NASA scientists. And I'm sure you're familiar with this program.
Yes.
And I'm very fortunate because I got some firsthand experience because my nephew was a participant a couple summers ago, and he's now an engineering student at Virginia Tech. And because of his experience, he's joined the Design Build Fly team, and they're competing nationally. So
That's awesome.
so it's, it really does have an impact on those students.
It does.
Now, you said in your response to Ms. Stevens' questions that you felt NASA believed that you could make just as much of an impact in other areas with other programs. Is that correct?
So as far as the universities go, we do a lot of missions with a lot of universities, and then universities actually are very good at engaging young folks in the programs that they're developing. And so we do a lot of that activity even outside the space grant program. But certainly I understand your point.
And so you're liaising mostly now with the universities, and kind of you don't have an equivalent program for high schoolers to the space grant program at this time.
Not equivalent to the space grant, but we do activities with high schools all the time when it relates to, like I mentioned, the robotics. The first robotics competition is a high school competition. NASA spends about $4.5 million annually invested in that program, and we also provide scientists and engineers as mentors for the high school students. So we do these kind of activities within the mission directorates.
But they wouldn't necessarily be a week-long structured program at like NASA Langley or something like that.
In some cases, we have activities similar to that. The first robotics competition is multiple days long, but it's not the space grant program.
Very good. Switching gears a little bit, we often talk about satellites in Earth science, but there are other new opportunities for the development of long-duration, high-altitude robotic aircraft that can fly into the stratosphere and accomplish a broad range of goals at a much lower cost.
That's right.
And one example of that is the solar-powered Odysseus aircraft, which is developed by Aurora Flight Scientists, which happens to be a constituent business of mine.
Okay.
Are you familiar with that aircraft?
I'm familiar with Aurora. I'm not familiar with the aircraft itself.
Okay. Are you familiar with the solar-powered aircraft that would fly up into the stratosphere and perform a bunch of functions?
Yes.
So I'm encouraged by the fact that it can serve as a platform to support a bunch of NASA's Earth science missions, like monitoring sea level rise, understanding drought conditions on crops, looking at flooding and severe storms, and they can do all that at a lower cost than many of the satellite technologies that are out there now. So can you talk about how the Science Mission Directorate plans to use these new long-duration robotic aircraft capabilities to support Earth science mission objectives?
So we in fact do currently operate unmanned aerial vehicles or uncrewed aerial vehicles for the purpose of science. We also use crewed vehicles within aviation. As far as that specific aircraft, I would be thrilled if you gave me a chance to specifically understand what it does and how we're either using it or maybe even have an ability to use it in the future.
Well, I can just tell you, for example, it's solar powered, so it doesn't have to come down for refueling, and you can just park it up and set it to go in like a circular motion, circular pattern. And with the right telecommunications payload, for example, it could have gone a long way to helping restore telecommunications to the island of Puerto Rico.
Oh, sure.
After the storm. So, there are many different possibilities, but also for Earth science. So,
yes, ma'am.
Is NASA exploring Earth science capability with unmanned aircraft?
Absolutely. Well, the answer is yes. As far as specific missions, I'm not sure. I know we do all kinds of missions with crewed aircraft. As far as what we do specifically for Earth science with uncrewed aircraft, I'll have to get back to you.
Okay. Thank you very much. I'll yield back.
Thank you very much, Mr. Brooks.
Thank you, Madam Chairman. Mr. Bridenstine, clearly orbital debris in space is a key challenge with Moon to Mars and International Space Station and a number of different space endeavors. I noticed your public quotes concerning India's testing of an anti-satellite weapon. What can NASA do to try to minimize the amount of space debris, either sponsoring or advocating treaties, or is there some cleanup mechanism? But what can we do to reduce the danger of astronauts, to astronauts from space debris?
It's an important issue. NASA has a role to play under the President's Space Policy Directive 3. We develop technology, we develop capabilities that ultimately, under Space Policy Directive 3, the Commerce Department would be responsible for space situational awareness and space traffic management. NASA has a role to play in technology development and capability development. I would also say we have a very different role to play, which is a role of, we are a tool of national power. We're a tool of soft power. And I think it's important for people around the world to understand that intentionally creating orbital debris that increases the risk to astronauts is not compatible with human spaceflight. And so if NASA can play a role there, encouraging people not to engage in these kind of activities, that's an area I think where we can benefit the world.
Was there any prior notice from India to the United States concerning their planned anti-satellite test and subsequent creation of this potentially dangerous space debris?
If there was, I was not aware of it.
Have there been any communications with India, either its military or space agency, subsequent to the test?
I sent a letter to the Indian Space Research Organization indicating that their activities were not compatible with human spaceflight.
Now, we have various agreements with India where we cooperate on space endeavors, do we not?
We do.
Is there any risk to those cooperative efforts because of India's increasing the quantity of space debris?
Say that one more time.
Sure, we have these cooperative agreements.
Oh.
India has done something that we're not real happy about because it puts our space assets and astronauts at risk. Is there any potential reduction of cooperative agreements with India as a result of their increasing space debris that is dangerous to our space efforts?
So the cooperative engagements, no, and I'll tell you why. I think it would be, we don't want to do anything asymmetric. If they're trying to go to the moon and it's in both of our interests for them to achieve that objective, then we want to continue to partner with them on that effort. And that, we have not changed any of our cooperative agreements based on that incident.
Entirely different subject. Where does the United States stand among nations when it comes to astronautics technology? And what policies do we need to ensure our country's status as a leader in aeronautics and aviation?
So what technologies do we need?
Where does the United States stand among nations when it comes to aeronautics technology? Sorry, I gave you two questions back to back. We'll just focus on that first one.
Aeronautics, we as an agency, we're in the lead in a lot of different ways. As a country, we're in the lead in a lot of different ways. I think the two big, actually a number of big things. Low boom flight demonstrator, we want to prove that we can fly across the United States supersonic without creating a sonic crack that ultimately could be disruptive to infrastructure and people on the ground. That capability, once achieved, I think is going to be transformative for human space flight within, or human flight within the atmosphere. When we talk about the X-57 program, we're talking about an all-electric aircraft capable of carrying humans and crew. If it can drive down the cost by 60% of fuel, then that could be transformative and enable airplanes to fly, I guess, productively for profit in regions of the country right now that are underserved because the costs are too high. So driving down cost increases access to aviation capabilities. That's the X-57 program within the Aeronautics Mission Directorate. And finally, I think urban air mobility and integrating unmanned aerial systems into the National Airspace System is a critical capability that will be transformative. And in fact, it's necessary for us to be the world leader in that endeavor, just for competitive reasons around the world.
Thank you, Jim. I appreciate your answers.
You bet.
Thank you very much, Mr. Lamb.
Welcome back, Mr. Bridenstine. I know it's been a long morning, so I won't keep it too long. But you've gotten a lot of questions about the cuts to the STEM office, and from what I can tell, you've suggested that someone at NASA or some group of people with the administration has made a decision that you can more effectively reach out and encourage young people through the directorates than through the STEM office. Do I have that right?
That's correct.
Who made that decision?
We go through an entire process as an agency, and it bubbles up from the bottom, and then we get, kind of all the different parts of all the different agencies make their cases, all the different parts of the agency make their cases, and then we have to make decisions.
Well, who made the case that the $110 million for the Office of STEM was not worth spending this year? Who made that case?
Ultimately, the budget request is NASA's budget request, so I will own that.
Okay. In my state of Pennsylvania, there's a Pennsylvania Space Grant Consortium, and with the money that they were getting from the NASA Space Grant, they were giving $4,000 scholarships to students who were either juniors or seniors at any accredited Pennsylvania college or university if they were enrolled in science, technology, engineering, or math. And it was specifically encouraged that women, underrepresented minorities, and persons with disabilities apply. All three of those groups are probably people that NASA would benefit from having more of, right? I mean, that's an issue we have across our government.
Absolutely.
Would you agree?
Yes.
So do any of the activities in the directorates give out $4,000 scholarships to students in college?
Not that I know of.
Okay. So if your budget as you've presented it goes into effect, the students, there won't be more students like this in my state getting the $4,000 scholarships from NASA as they currently exist, right?
That's correct. But I want to make sure, sir, you understand we will follow the law, and we are following the law, and currently those programs are the law, and we will continue doing that.
But I'm talking about in future cases, as a result of the budget, you're requesting that that program would no longer exist.
Correct.
Okay. And you'd agree, I mean, there's a difference between giving somebody $4,000 in tuition and loaning your scientists to a first robotics competition, right? I mean, there's a real difference in the life of the recipient between those two things.
There is. On the first robotics front, the reality is a lot of those, that's not a cheap endeavor. And so NASA does provide direct financial resources out of the Science Mission Directorate to the tune of about $4.5 million for those activities. And it enables children, high schoolers, young folks, it enables them to participate in ways that they otherwise could not participate.
Oh, and I commend you for that. I've met with the first teams in my district. It's an exciting program. You know, the $4.5 million pales in comparison to the 110, and then interestingly, the 110 really pales in comparison to the $20-some billion overall NASA budget. So it seems to me a little maybe penny wise and pound foolish to eliminate $100 million out of a $21 billion budget. I mean, do you think that $110 million is going to be the difference between whether we get to Mars or not, whether we get to the moon or not?
No,
$10 million?
I absolutely do not.
No. So, I mean, kids are hanging on by a thread in college, especially in Pennsylvania. Pennsylvania is an expensive place to go to college. Our state colleges are financially extremely stressed. $4,000 could be the difference between staying and dropping out, especially for someone who comes from a background where their family is not wealthy, which is a lot of people. So I just really would encourage you to think this one through, and I know the request has been made. Congress is going to do what it's going to do, but this means a lot to people in my state, and in future years I hope it gets a little bit more respect and thought from this administration.
I understand.
Thank you. I yield back, Madam Chairwoman.
Thank you very much. Mr. Sherman.
Okay. I know others have had a similar line of question about SLS and Orion. You said that SLS, Orion, and the ground systems are the backbone of our nation's deep space exploration program, starting at the moon and beyond.
Yes.
My questions concern the budget, which seem to contradict your statement. After years of delay, in part due to insufficient requests and continuing resolutions, SLS, Orion, and their respective ground systems have made significant strides which will bring an unprecedented exploration capacity to the nation and really the rest of the world. The engines are ready, capsules are being tested, boosters are ready, pads and infrastructure near completion, and then there should be a roll of music there. And then the Trump administration delivers a budget that aims to halt and slow this progress. Is there a rocket and crew capsule that exists with the same or greater capacities as SLS and Orion?
No, sir. That is, as you correctly said at the beginning, and I still believe 100%, that is the backbone of our ability to get to the moon. It's the backbone of our deep space exploration capabilities. What we did in the budget request is we delayed for a period of time the exploration upper stage specifically because we've been having challenges with the core stage. We have to get the core stage complete, and we can fly the core stage with what we call an interim cryogenic propulsion stage and an Orion crew capsule with a European service module, and we can take that, in fact, to the moon, and we can take it to the moon with humans. The exploration upper stage is absolutely important for the future, but given where we are right now with SLS, we wanted to focus all the resources specifically on the core stage.
But you seem also to be seeking money for a rival approach that may not yield a launch or a lander. What alternatives to SLS and Orion are you seeking funding for?
So right now, we did a 2-week study on commercial alternatives to the SLS, and what we found is that none of those commercial alternatives are going to help us save on cost or improve the schedule.
So this is a 2-week study?
We did a 2-week study. I learned a number of weeks ago that the SLS was going to be delayed again. And I made a determination that we need to find an alternative approach. We looked at all of the commercial options, heavy lift rockets. Going to the moon is extremely hard. It's a long distance, and the mass that we need to send there is a lot. And so the SLS and the Orion crew capsule are the tools by which to achieve that objective. Commercial solutions in the future could be viable. In fact, they will probably be necessary. But at this point, SLS and Orion are the best approaches to stay on schedule.
So contrary to my understanding of the budget request, and I may not be reading it with as keen an eye as yours, you're full speed ahead on SLS and Orion, but the upper stage of SLS, you're the so-called EUS, you're going slow on only for technical and not budgetary reasons?
We made a determination that we needed to focus on that core stage, and until that core stage is complete, the exploration upper stage ultimately doesn't have any value because it needs that core stage to be effective.
But why not go in parallel? Why do you need? I mean, you're developing capsules in parallel with rocket engines, suits in parallel with capsules. Why is focusing on the first stage causing you to halt efforts on the second stage?
Ultimately, because we're making determinations based on the constraints of the budget.
So how much does this slow down the process? You got to first get the first stage right, and then you'll wake up and say, "Oh, now we've got to do the second stage." What delays are we talking about here?
So it's very possible that next year you'll see the exploration upper stage in the budget request. It's very possible, given that we now have an agenda to get to the moon in 2024. In the coming days, you might see that as part of the architecture to accelerate the moon mission with an amendment to the budget request.
So we may see an amendment to the budget request regarding the first and second stage.
It is possible, yes, sir.
I yield back.
Thank you very much. I now recognize Ms. Hill.
Thank you, Madam Chair. Mr. Bridenstine, NASA's workforce has experienced significant aging in the last 25 years. According to the Space Foundation's The Space Report in 1993, 34% of NASA employees were under 35 years old, and 15% were older than that, or than 54. By 2018, these numbers have flipped. Just 15% of NASA's workforce is under 35 years old, while 35% are older than 54. and we're seeing this play out in my district. Do you have any concerns about the aging of the NASA workforce, and what do you plan to do about it?
Yes, ma'am, 100%. We have a bow wave of retirements that are on the horizon. We're working very hard to make sure when that happens that we have people that can fill in and take those roles at every level of leadership in the NASA organization. So in order to achieve that, we are working with universities, with missions and other capabilities to make sure that when people graduate from college, they not only have the academic capabilities, but they also have hands-on experience actually developing missions for NASA. So that's one way that we're working to make sure that we're filling in for the retirements. We're also working through internship programs and, in fact, middle career kind of programs to get folks focused on maybe joining NASA.
Thank you. I guess that kind of relates to Mr. Lamb's question of how the reduction in scholarships might be impacting that.
Yes. Again, so we work with universities in a whole host of different ways through the mission directorates, and we intend to keep doing that. And they're a key piece of how we're going to fill this this retirement wave that we see coming.
Do you have like real projections laid out in terms of how the impact's going to look, and is there a way that we can be involved in that process or informed?
We
in that
do.
process?
I'd be happy to get with our HR folks and sit down with you and talk about it in detail.
Thank you. And then the second question is, according to the Space Foundation's The Space Report, between 2011 and 2017, the average NASA salary decreased 10% in real terms. We also heard, I have many NASA employees in my district who told me about the impacts that the shutdown had on morale and on people seeking other outside employment, especially when we have massive aerospace industry in our district that's outside of the government. And are you concerned at losing and not attracting highly skilled scientific and technical personnel because of those decreasing salaries and competition from the private sector and instability in government pay?
This is a real issue for NASA, and we're dealing with it every day, especially in our, a lot of our centers are in expensive areas. Ames, for example, is a very expensive place to live out in the San Francisco Bay Area. It's where a lot of talent is, so it's a good place for us to be. We can take advantage of all of that talent. At the same time, our employees make a government paycheck, which is not competitive with the area in which they live. The folks that work at NASA do it because they absolutely love it. They're committed to what we do. It's unique in the world, and everybody knows it, and they want to be a part of it. But certainly we are working through some really significant challenges when it comes to how we compensate our workforce.
Yeah, I'd be interested in working with your HR folks on that too, and looking at different compensation mechanisms.
Absolutely.
And then lastly, Vice President Pence said that if NASA can't land on the moon by 2024, we need to change the organization, not the mission. So what does the changing the organization mean to you? And do you see this as a threat to breaking apart NASA or otherwise drastically reorganizing the way that civil space is implemented in the executive branch?
No, I don't see it as that. I mean, I know exactly what he's talking about. He's talking about the fact that you know, there has been maybe a sense that since it's been a long time since we've flown humans into space. The retirement of the space shuttle was in 2011. The gap was not supposed to be this long. So the question is there complacency? What he said was, we're fighting complacency. So he wants to get us moving faster. I think that there is a big difference, and going back to the organizational structure, there's a big difference between operations, which is what we have on the International Space Station right now, commercial resupply, commercial crew, and operations on the International Space Station. There's that part of NASA, and then there is development. The brand new things, the big rocket to get to the moon, the gateway, lunar landers, all of those capabilities don't yet exist and yet soon will. That's development. That's very different than operations. So what we're working on now is a plan where we would actually have a mission directorate focused on development and a mission directorate focused on operations. We don't call it the Development Mission Directorate because development is not a mission. We call it the Moon to Mars Mission Directorate. And so we're working through right now the process by which we could have that online in short order to help us achieve a faster lunar landing.
I can appreciate that since my grandfather was an engineer on the space shuttle in the Apollo series.
Oh, wow.
Thank you.
You bet.
Thank you very much. And before we close the hearing, I want to thank our witness very much for your long steadfast testimony this morning, and to remind, you can now be dismissed, and I want the remaining committee members to understand that they. We have another member who just arrived. Oh. I dismissed you a little too early.
Okay.
Yeah. Okay, come right in. What's his name? Swartz. Mr. Swartz is recognized.
I almost got away.
You did, Mr. Bridenstine. Apologies, and it's nice to actually occupy your office. So thank you for
216 Cannon?
216 Cannon. Thank
The
you
best.
for keeping that warm for me. And I represent the district that starts just north of the Cape and heads up to Jacksonville with Embry-Riddle.
Oh, good.
At the center there, and so obviously space is in our DNA, and we're just so excited and thrilled with the growth of commercial space in particular, but just also the kind of the resurgence of what's going on. I just left Secretary Wilson and General Goldfein and the House Armed Services and talking about the future of space there from the military side. So, Administrator, as you know, the Kennedy Space Center is in Florida is the site of the world capable, just really incredible, of launching astronauts into deep space, just an incredible capability. Do you know, trying to think how the best way to really phrase this question, can you just talk to me about the Vice President's directive?
Yeah.
To get to the moon, and apologies if you've already gone over this, but,
Oh, no,
but it's critical to I think, growth in Florida and where we're going with it, and particularly how you plan to do it within the timeline.
Right.
Given your budget requests and the perceived, at least, disconnects there.
Absolutely. So going back to I think it was February of 2017, the President signed Space Policy Directive 1. In that Space Policy Directive, he said we're going to go to the moon.
Mm-hmm.
We're going to go sustainably. In other words, this time when we go, we're actually going to stay. That doesn't mean we're going to have a permanent human presence on the surface of the moon necessarily, but what it means is we're going to have permanent access to the surface of the moon with humans, but also with landers and robots and rovers. But we're going to go sustainably. We're going to go with commercial partners. We're going to go with international partners, and we're going to retire risk, prove capability, and then we're going to take that to Mars. So that, I think, was the foundation of what the Vice President announced last week. We put together a plan to achieve that objective, given the budget constraints, and we came up with a 2028 landing date on the surface of the moon. The President and the Vice President determined that they wanted to go faster than that. So they gave us an objective to meet that deadline of 2024, which, of course, puts, we're going to probably need different resources than we had previously anticipated. But I will tell you, the agency, NASA, is exceptionally excited about this opportunity. I would imagine down at Kennedy, where you are, there's a lot of really excited folks right now. And I think at the same time, not just a level of excitement, but people know that we can achieve it. We know that we can achieve it. And so the goal here is to go to the moon and go quickly, but also go sustainably. And so that's what we're working on right now to develop what that plan would look like. All of the elements are there from the plan that we had previously from 2028 landing. All of the elements are there. Some of those elements we need to start moving forward, which means we're going to need a different set of resources. And so in the coming weeks, I'm going to talk to this committee and others about what those resources might look like.
Thank you. And the time I have remaining, the budget proposes the termination of NASA's Office of Education zeroes out the education account. So within the Office of Education's the Aerospace Research and Career Development Program, that houses the National Space Grant College and Fellowship Program. That's incredibly important to Embry-Riddle, along with a number of other universities that are focused on STEM, but particularly with Embry-Riddle. We educate world-class STEM talent. I think the race into space and the 21st century space race is really an icebreaker for pulling the United States back in its world leadership role in STEM. How does the President's budget request impact that space program, that space grant program?
So the space grant program specifically would not be funded in the president's budget request. It is true that when we think about how we go about inspiring that next generation, we do it through STEM activities. We're looking at doing that through the mission directorates, which we have a number of programs through the various mission directorates to accomplish that end state. And so, again, prioritizing what's the biggest impact for the agency, what's the biggest impact for the country. We determined that it was best to not fund the space grant program, but at the end of the day, right now it is funded. We are following the law, and we're committed to following the law.
Madam Chairman, thank you so much. I appreciate your forbearance. Thank you. Thank you, Administrator.
Thank you.
Thank you very much. And again, thanks to our witness. You've been an excellent witness. We appreciate you being here. And I think that is our last questioner. So the record will remain open for 2 weeks for additional statements from the members and for any additional questions the committee may ask the witness. And the witness now is excused. Thank you.
Thank you, ma'am.
The meeting's adjourned. Not really. I think what I did was